A very good morning, everyone, and a warm welcome to this exciting edition of AI Pathshala, brought to you by KTech Data Science and AI Center of Excellence at NASCOM in association with Microsoft. My name is Supriya Samuel, and I'll be your host for the day. In this module, we will take you through some of the leading innovations at Microsoft in artificial intelligence and machine learning. This session will establish a foundation for you as we delve deeper into key emerging topics of this modern computing era. It gives me an immense pleasure to introduce our esteemed presenters from Microsoft today. Meet Sandeep Alur, who is currently the technology leader at Microsoft India. Sandeep Alur heads Microsoft Technology Center, an experience center focusing on helping customers accelerate their digital transformation journey. He has held various technology leadership roles in his 23 years of industry experience, providing technology and architectural guidance. His experience ranges from dot-com days to the distributed cloud computing to the next generation intelligent computing era. He has architected solutions across technology platform landscape and is a stern believer of his own philosophy, which says enterprise architecture is an evolution and it grows with innovation. From an innovation standpoint, he believes that the next big leap is in data science and AI will elevate customer experience to greater heights. Joined by Sandeep today is Shikha Agrawal. Shikha Agrawal is currently the Senior Data and AI Architect at Microsoft India. As an AI leader, Shikha is facilitating transformation to intelligence-driven organization by harnessing insights from data using the power of cloud computing and artificial intelligence. Shikha is passionate about working with business leaders to evolve a strategy for modernizing the data estate targeted at end goal of achieving core objectives. She has a hands-on experience in identifying opportunities to optimize and automate the processes by developing intelligent machine learning based solutions, thereby increasing revenue, reducing cost, and improving customer experience. We are really delighted to have the presenters from Microsoft today. A few guidelines before I pass on the baton to the presenters. We understand it's a 4-hour long workshop, hence we will be taking regular breaks and our presenters will apprise you on the schedule. Please feel free to queue in your questions in the chat window, which will be taken up during the session itself. Also, we will be rolling out a survey form as we would like to provide your feedback on the workshop. Without any further ado, I would now like to invite Sandeep to kick off the workshop.
Awesome. Supriya, thank you so much. And thanks for the warm welcome. Shikha and I are absolutely delighted to be here this morning and take everybody through the journey of art of the possible on machine learning and AI. So again, warm welcome to everyone. Good morning. And I think it's a weekday. And all of you joining speaks volume of the fact that, yes, you want to invest in learning. You want to invest in upskilling. So truly thankful for all of your time this morning. So what we'll do is, quick housekeeping. Supriya mentioned, but I'm going to just, put it out on the table once again. As you are on the call today, I would say two things. Number one, yes, we have a structured approach towards disseminating knowledge today, right? We have 6 capsules that we want to bring to the table. After 2 capsules, we're going to take a break, right? So there's sufficient break between that. Number two, keep asking questions when in doubt. Yeah. So when I say ask questions, drop a question in the chat window. If Shikha is presenting, I will moderate the chat conversation. If I'm presenting, Shikha will moderate the chat conversation, right? And if that question is of very important, if the question is important and everybody should probably understand it broadly, so we'll take it up and we'll probably speak out that question and answer that. Yeah. So otherwise, request all of you to stay on mute and switch off your video as well, just so that we save bandwidth. In the end, we'll have sufficient time and would love for all of you to switch on a video at that time. Last 30 minutes should be an interesting conversation that we can make, and would love to hear your thoughts, feedback, anything that you want to understand more, because we're also going to be talking to you tomorrow, right? Tomorrow also we're going to be talking to you for 4 hours. So We can bring some of the stuff which you felt, hey, can you talk about this? Give feedback. We'll try to see if we can do it tomorrow. Yeah. Otherwise, it's going to be packed morning. And Shikha and I have spent significant time preparing for these 2 days. And all I can tell you is we'll not disappoint you. Yeah. So that's true. In fact, one last thing from mine before I kind of start sharing my screen and present for the first 15 minutes to give an overview. I'm sure all of you, by the way, this Pathshala involves good amount of hands-on labs as well as demos from our end. So when it's a hands-on lab, I think expectation is that each of you will have a trial Azure subscription at your end. Yeah. So if not, it won't take much time. Just sign up, and because some of the demonstrations that we're going to do or hands-on lab that we're going to do, you can follow us, right? And again, if you can't keep pace with us, we you can always will give you link tutorials in the chat window. You can probably take it up offline and learn at your own pace, right? Because my belief is when somebody's presenting, it's always good to kind of watch what they're doing, understand or ask questions and get clarifications. And later, when you get sufficient leisure time at your end, you can practice it. Yeah. Perfect. So without much ado, let's get going. I know people are still joining in, which is a good thing. On a Thursday morning, Thursday is a happy day, right? Because Friday is not too far and we all feel good about Friday. Yeah. So let's get going. So first things first, yes, this is about how machine learning and AI on Microsoft is helping us transform key experiences, right? By the way, most of what we want to speak today, you might be wondering, what does experience got to do with it, right? By the way, you should know this. Everything you're doing in the world of ANML is purely to see how we can elevate experiences, increase productivity, right? Quickly, now, more than ever, right? When I say more than ever, see, AI is something we've been speaking for the last 4 or 5 years with utmost authority, right? When I say authority, that means this technology is going to change the world. This technology is going to make a huge difference in society. All this stuff is absolutely, good things to look at how technology will make a profound impact in society. But I think more than ever, in the last 18 months, we realized that customer needs are changing with each passing day, right? Be it in the healthcare industry, retail industry, manufacturing, public service, it doesn't matter. Across the board, there is significant change happening. And this is where technology will have a profound impact. And more than ever, AI will have a significant role to play here, right? We're not talking about, technology is going to change the world. Yes, technology is changing the world as we speak, but AI's role is significant in that trail, and we'll speak. Most of what you get to hear from us is all key innovations on that trail. And again, you just look at this, right? Today, if you're at home, and you've right from the time you sip your morning coffee or a tea till you've kind of start working, do your purchases, switch to music at leisure, and eventually when you wind up end of the day, you are in a connected world, right? You are based in midst of experience, right? Imagine you join the Teams call today, right? It's an experience for you, right? I mean, the team should offer an experience which is favorable to your environment. I mean, whether you purchase on a Flipkart, Myntra, Amazon, or even for that matter, when you go on an evening walk and your watch telling you or a phone telling you that, hey, you walk so many steps, it's an experience, right? I mean, your statistics is constantly being available to you, and that's what gives an experience, right? So this is truly an arrival of an era. And again, when I said customer needs are changing, because customers asks are surmounting every single day, technology's role is to make it happen without without pretty much being the front door, right? It has to be in the back seat. It has to be in the back seat. Technology to take a back seat and experience to take front seat, right? So in that context, bulk of what you'll get to hear from us today fits to this construct, right? Which basically is a multi-sense, multi-device environment is all of us live in, right? We're talking about experience to be intelligent led, and of course, anytime, anywhere, any device, because we are in that era right now. Like location independence is so central to everything we do on a daily basis. So hence, ubiquitous computing is truly reality. And bulk of what you'll get to hear from us will go across these two elements, which is intelligent cloud, intelligent edge. Of course, all of you may understand intelligent edge. We're talking about edge computing, right? Edge computing is very real today for the simple reason that is 5G is around the corner. AI at the edge. See, a lot of what you will get to hear from us, though it's a capability feature, it can it can be taken to edge computing infrastructure seamlessly. We'll talk as we go along. Now, no industry is left behind. Every single industry is being impacted in a positive way, to an extent of, they're looking at technology which never they thought earlier, right? So technology decisions which were parked for future, all of them have come to the foray, and every single industry is looking at how technology can be put in. Of course, more than technology, how can automation powered by intelligence can lead the next transformation that they want to do. Okay. Now, the top of mind for every single business today, right? So is to become intelligence driven. So now the 8 hours of content that we have today and tomorrow eventually aligns to this philosophy saying, yes, I want to ensure, I want to infuse intelligence into every single business process that I have in my company, every single consumer endpoint. I want to see if I can apply intelligence. I want to ensure I can monitor my environment in the most intelligent fashion, make decisions which is supposed to be more scientific, right? That's the era. Now, I said earlier, when you're building a solution today, right? Let's take speech, let's take vision, let's take language. You're not looking at everything to be existing in one design thinking, which is public cloud. No, you're looking at solutions will pan across edge infrastructure and cloud infrastructure, right? When I say cloud infrastructure, dominantly what you do today is train your machine learning models in the cloud because you need compute horsepower. Training in the cloud, and once you're trained, once you're happy with the precision and accuracy, you take that to edge infrastructure so that you can do inferencing closer to where data is getting generated. Simple example to make it very clear is if you look at video surveillance today, right? A lot of spatial analysis being done as we speak across retail, healthcare, and manufacturing plants. Now there is video cameras all over the place. It doesn't make practical sense for us to take video feeds to the cloud, right? I mean, look at the bandwidth and amount of data you're going to be pushed into the cloud, not practical. And at times you may not have connectivity also. Hence, the need of that is to, I want to do inferencing where data is getting generated. That means video feeds are generating data. Can I infer right there, right? Maybe inside in the camera compute itself or somewhere in the on-premise infrastructure. So when I say solutions will pan across two environments, that's what it means, right? Now let's talk about, before we jump into the 6 capsules I mentioned, I thought it makes sense for Shikha and I to kind of, give you a backdrop of what is Microsoft AI platform. Just a glimpse of, yes, this is the all the building blocks of a platform, and then we'll slice and dice it as we go along. Yeah. Um, Now, quickly, now while I take you through this, it will be good if each of you who are joined, just drop one message in chat window. If you're a developer, message a developer. If an architect, put an architect. Yeah, architect, a developer. Okay. So, I mean, when I say architect, somebody, I'm talking about somebody who is responsible for designing, architecting, and designing a system. If you're a developer, you can be a enthusiast or you're actually a hands-on developer. So just type in, if you ask me, if somebody asks me what am I, I'm going to just put that in chat. So for now, while I'm going to take next 5 minutes, just drop that message, developer or architect, each one of you. That will help us to understand who is who in the car. Yeah. Now AI at scale. So here's the deal. As Microsoft, when we're looking at how do we innovate in the modern world and how do we offer that innovation to our the larger fraternity in the on this planet, the question is scale, right? We can't offer something which is so good but it can't scale. No, AI has to be at scale, right? And that's where, if you look at our approach, has been to offer models. And you can call it as applied AI services, right? And a platform which will help you build custom models. And of course, there is also a supercomputer. Today, we are the luxury of going to the public cloud, spinning off a virtual machine, and let's say, bring the Jupyter notebooks, right, and start programming, right? I mean, that's the ease at which you get environment. Now, imagine I have probably a very profound problem in the society, which is, let's say, I want to look at cancer prediction as an example, right? Or genomics as an example, or land records. No, that needs massive computation to happen, and that probably goes beyond the boundary of a GPU cluster that we might have. So you may need supercomputer because you want to probably get to inferencing faster. So that's where, going forward, each of us getting access to supercomputer where we can deploy and run the models is not too far. That's where, as Microsoft innovating, with OpenAI there in terms of making sure we handshake with them. Of course, for folks who may not know OpenAI, OpenAI is an independent research group who basically are innovating in the area of artificial general intelligence to ensure they bring impact of AI to larger society, right? So look up OpenAI, and we have a partnership with Microsoft, and I think Shikha will speak about that as we go along. Now, breakthroughs have happened all these days when it comes to AI, be it speech, language, decision, computer vision, right? So all of those innovations have happened. And when you say human parity here, you might see in my slide, there is a keyword called human parity underlined here, right? Human parity means ability for machines to basically surpass human accuracy. If I'm talking about, let's say, speech technology, ability for machines to understand speech, the way we converse, ability for technology to actually emote like we emote in terms of text to speech, that has crossed human parity. Means it's very you can't different. Earlier you could differentiate between a machine talking and a human being talking, right? So today I think there is a very blurred line. That means you cannot make out whether it's human or a bot speaking because of thanks to neural I would say networks, the ability for us to bring in a lot more deeper models which are highly accurate. That's a reality. So with that, let me just get to this one pretty slide, which is where I will spend some time, and also this is where I'll hand off to Shika after the slide as well. Yeah. So for all of you who joined today, when you say, what is Microsoft AI platform, right? So what does it comprise of? What are the building blocks? So three buckets here: applied AI services, infrastructure, and tools, right? It's a perfect handshake between all of these three things, because end of the day, when you're a data scientist, right? By the way, I forgot, if you're a data scientist, you should probably put a message saying data scientist. Just developer, architect, data scientist. Just put those key terms there. Okay. Now, applied AI services. So look at it this way. Now, again, there are three subcomponents here. Um, Applied AI services are dominantly your pre-built AI models, right? We call them cognitive services, right? That's something which you saw me earlier talk about: AI innovations, breakthroughs. Now they come under three or four categories, which is computer vision, language, speech, decision, and search. Five categories, right? So, and just so that you know, these are cloud services, and when it comes to edge, yes, these models can be taken to edge infrastructure also. That's a beauty. You will speak as you go along. Conversation AI, this is again bot service, custom AI, machine learning service. So when it comes to consuming battle hard, world-class models, yes, those are pre-built AI models. If you want to build your own custom model, that's where Azure machine learning service comes into the foray, right? That's on the first one. Infrastructure, yes. So the fodder, the resources for any machine learning exercise is data, and that's where I think there is the plethora of offerings on Azure when it comes to data storage, analytics, etc. When it comes to AI compute, yes, you can spin off a data science virtual machine, and you also, if you look at Databricks and Kubernetes service, Edge, all the stuff, is part and parcel with infrastructure. Of course, you get a choice in terms of spinning off whether you want a CPU, FPGA, and GPU, right? You can choose which infrastructure, which compute environment you want to pretty much. If you want to create a cluster for training, you can choose depending on how economics work out for you. By the way, I'm sure CPU, all of us are aware. GPU, if you look at it, they are not cheap. They're expensive, but they're highly, I would say, they give you the horsepower to run large scale models. CPU, of course, is cheap, but processing power is not as much as GPU. But FPGA, programmable gate array, that gives you the flexible, that gives the best of both worlds, right? I would say GPU performance at CPU cost. That's what it's touted as. If you look at Intel, Nvidia, we talk about FPGA. Okay. Number three, tools, right? So tools, these are the most. This is probably the make or break for any developer, data scientist, or architect, right? So end of the day, you need to be equipped with a familiar tool set which will help you stay productive. So of course, notebooks, design, automated machine learning. I think we'll speak what they are. I'll not spend too much time on this as we go along, but our machine learning service gives you all these capabilities to help you. Again, different personas, right? If you're a hardcore developer, you want to be notebooks. If you if you if you want a low code environment, it's designer. If you're automation, automated machine learning, right? Again, the platform supports all deep learning frameworks, and of course there is something called ONNX. I'm sure you would have heard of it. It's open, neural network exchange, right? That's a interoperable standards that Microsoft and a few others have got together and built. That means if you build a deep learning model today, let's say using Cafe, and you want to take that model and import in TensorFlow, as long as you embrace ONX, I would say interoperability standards, you'll be able to kind of take it across. Now, last two building blocks, right? So MLOps, right? This is something which is a dire need. Probably 3 years back, nobody spoke more about it because the number of models they're building were also less. Now, it's you pretty much every single day are churning out models, and you have to have an automation place where new data comes in, training has to happen. If there's accuracy is higher, deploy it to production. Otherwise, no reinitiate retraining, etc. So all this stuff has to be done relentlessly, and that's where MLOps comes in. And of course, the most important of the lot, which we'll speak tomorrow, again, Shikha is going to speak about it as well, is responsible machine learning. Each of us as developers, we have to stay accountable in ensuring that the models we build, you bake in responsible AI design principles, right? What they are, we'll get to know as we go along. But otherwise, this is one pretty picture in terms of what is the Microsoft AI platform all about. And these are 4 or 5 building blocks, which basically comes together to give you that highly sophisticated, simple, I would say simple and sophisticated platform for developers, data scientists, and anybody who wish to use the services. Be it AI enthusiast with low code or no code you want to consume, absolutely possible. Okay. Again, everything we spoke so far embraces the design thinking, which is intelligent cloud, intelligent edge. That means edge is the reality, and all the stuff you do here can be taken to edge without a glitch. Okay. So with that, let me take a pause here. I think we're good on time. First 15 minutes is where I'm supposed to spend an overview. And this is where I want to hand it off to Shikha. Shikha is data scientist at the tech center that we are in right now. And I'll let Shikha take it from here. And I will go on mute. I'll switch off my camera, but I'll be active in chat window. If you have any questions where Shikha presents, I'll orchestrate that. Yeah. With that, Shikha, over to you, and you can take it from here.
Thank you, Sandeep. So yeah, so with that, I'll get started with the first topic for today, which is automated machine learning with Azure Machine Learning Platform. So I'm sharing my presentation for that, and then I will take you through certain demos in this area. So I can see some people are still joining. Yeah. So if we talk about machine learning today, right? There is like I mean it is the it is very very prevalent today as Sandeep was mentioning in every vertical. We are seeing a massive adoption of AI. So be it for fraud detection or for customer recommendation model or for being able to gauge sentiment from conversations. Today, AI has almost come into center stage. And if we look at various statistics today, AI is being used, most people say that it is being used at least in one business function. That is what 49% of the people kind of share. And it is instrumental in boosting customer experience, in driving business insights, and increasing employee productivity. So bottom line is it has become almost imperative that we utilize this vast volumes of data and the power of improved AI algorithms and cloud computing to really fortify our digital capabilities and to be able to deliver a better experience to customers. Now, if we talk about like as we get started on this journey, right? There are a couple challenges that we face. I mean, typically, as data scientists, as we begin experimenting with data and try to unlock insights from all of this historical data, um, we see that we take a lot of time in actually building solutions that we can operationalize it. And some of the factors that essentially lead to this experience are really like a lack of versioning, right? So data science by nature is a very iterative process, right? The first model that we train is not going to be
close to our expectations. So we will really iterate. And sorry, I saw a comment. Is there an issue in kind of being able to see the content?
No, it's perfect, Shikha. Please go
All
ahead.
right. Great, great. Thank you so much, Sandeep. Right. So yeah, so the lack of versioning of the models, that is like one major change that we challenge that we face, right? Then, of course, ability to ultimately, we want to unlock insights from the data, and we want to really innovate faster. Um, just give me a minute. Just give me a minute. Right. Sorry about that. Yeah. So the other challenges that we see is that there are many, many frameworks, many, many languages, and how do we essentially work with a flat platform that really works with all this seamlessly? Then how do we operationalize these models? How do we deploy these solutions at scale? So these are, and how do we essentially build solutions that conform to the thematic of responsible AI? So these are some of the challenges, because of we really need a platform that tackles these challenges and gives us a seamless experience. Now, this is where Azure comes to the, actually provides a platform that enables us to work, or rather infuse intelligence into our applications very, very easily. Now, just to give like a broader perspective of our AI offerings, we have cognitive APIs, which are essentially APIs exposed and available to you for ready consumption. So, what has happened is, in the field of computer vision and NLP, Microsoft has invested billions of dollars over last many, many years. And it has then made available to all of us all this research that has gone in for last many, many years, and expose them as APIs. And so in the realm of NLP, computer vision, decision making, we have these readily available constructs that we can utilize without investing in very expensive data science projects. The second is, we have actually built a lot of solutions by utilizing services across domains. So, like, we have cognitive search, which will essentially enable you to do text mining. So you may have many, many, kind of documents, and you want to unlock insights from all those documents. So there is something called as cognitive search, which makes use of computer vision, which makes use of NLP, and which also combines several other functionalities to give you a seamless experience when it comes to text mining. Then we have something like form recognizer, which essentially extracts information from various documents. So be it like your ID documents, your invoices, your receipts. Today, all the process of extracting information from these documents can be automated. Um, and then we have custom machine learning platform, which is really the topic of the current session, which is termed as Azure Machine Learning Platform. Now, the question is, why do we really need machine learning platform? So, if we talk about a typical, data science life cycle, it essentially involves data preparation, training the model, deploying the model, and then monitoring and managing it. And with a platform, you're able to perform each of these tasks with ease, managing structured and unstructured data, taking care of your audio data, video data, semi structured data, and be able to train models, deploy them in the environment that you want. So you may want to deploy the model in a container, or as you're in a testing phase, or you may want to deploy it on Kubernetes environment. And with the platform, you're able to seamlessly do that. And we'll talk more about it as we go forward. So essentially, with a platform, the key thematic is that you are really able to focus on your business problem, rather than getting bogged down in the operational aspects, in the governance aspects. Basically, what you get is an improved time to value with rapid innovation and integration tools. With MLOps, you are able to operationalize at scale. Uh, when we talk about anything related to data, security is foremost important and importance. And so with the platform, you can be rest assured that the security aspect is taken care of. And um, over and above, developing responsible solutions. So this is something that actually enables us to productionize our models. So typically when we talk about model training, right, we say that my model is giving me so and so accuracy. Now, let's say a model might be giving me 95% accuracy, and I might feel quite satisfied with it. But how do I know that the model is having this much accuracy over the various data points that I have? How can I be sure that it is not being fair to a certain, let's say, gender or demographics? And if that is happening, right, I will be very, very uncomfortable deploying the solution. So, like, if let us say I was building a solution by which I wanted to kind of detect the state of traffic lights, and the model was giving me, let's say, 95% accuracy, but then it was, say, just 70% accurate during daytime. uh, I will not be able to, I will not be comfortable deploying the solution. So these is something that very, very important when we work with models, and that's all comes into responsible AI thematic, and we'll talk about that more later during the day. Um, so with Azure machine learning platform, we get the edge, we get the differentiation experience with all these requirements being taken care of. So I mean, we get a seamless studio experience. It caters to the data scientists of all levels. So with ranging from custom notebooks to designer experience to automated ML, we are able to cater to all scenarios, be it from a low code, no code environment to a full-fledged custom TensorFlow or any kind of model. Now, when we talk about automated machine learning, right, what exactly is automated machine learning? So if you have a scenario wherein you want to train a classification model or a regression model or a time series forecasting model, um, and shortly, we will also have into automated machine learning a provision to train computer vision classification models. So if we have these scenarios, we can easily utilize automated machine learning. Now it will do the entire task of understanding basically data preparation, feature engineering, running multiple algorithms, and tuning the parameters, and then it will tell you which is the best performing model. Now, if we look at the typical model creation process, we start with like, what features should I use? What algorithm will give me the best results? And even for an algorithm, like if I were to use some a decision tree algorithm, what need to be the hyperparameters, right? How many leaf nodes do I need to have? What should be the depth of my tree? So there are many factors that essentially make this entire process very, very, time consuming. And with automated machine learning, we don't have to worry about any of this, right? So if we look at the detailed workflow here for classification, regression, and time series forecasting, what we do here is we just give it the data set as the input. It does the feature engineering for us. It trains the model on multiple algorithms, it applies multiple hyperparameters, and finally, it gives you a leaderboard wherein you can see which model with what hyperparameters had what accuracy. Similarly, in Azure Machine Learning Platform, we have a designer experience wherein we get a little more flexibility as compared to automated machine learning. But again, it is a drag and drop interface. So we can essentially select our data set, split it into training and test data set, and apply various data transformation logics that are available. We can then train the model, evaluate it, and so on and so forth. And there are multiple functions that are available to us, and we can apply those functions in just by a drag and drop facility. And then, of course, we have collaborative notebooks wherein we can do anything and everything under the roof as per the need that we might be having. So, with that, as we train models, we can actually work with the familiar data science tools. We can work on Visual Studio. We can use Jupyter notebooks. We can use PyCharm, or basically with Azure Machine Learning Platform, you can continue to use your familiar tools while harvesting the various benefits that you get, and they will become more apparent as we go forward with few of the demos. Most powerful platforms are supported in the platform, so ranging from TensorFlow, PyTorch, MXNet, Scikit-learn, Keras, all the platforms are supported here. And um, another aspect that I want to kind of share with you, when we start working with machine learning, right, especially in the realm of computer vision, uh, the first thought that comes to us is, where will I get the compute from? And that essentially delays the entire sort of projects. So first thing is, how will I get a GPU, right? With Azure Machine Learning Platform, you can within minutes spin off a GPU or even a GPU cluster with the required resources. And within few minutes, you can be up and running. You can be utilizing, whatever compute that you want. And good thing is, we have made every effort to make sure that you incur minimal cost. So you can set up policies like, if the compute is not being used for, let us say, 5 or 10 minutes, then you can, shut down the compute automatically. So with that, you get the benefit of being able to utilize the required compute almost instantaneously, and also pay for only what you use, right? So this gives us tremendous benefits. Now, just sharing few of the machine learning scenarios. So if we talk about manufacturing, predictive maintenance is something that we see almost every manufacturing organization utilizing AI for. Then talking about fraud detection, and in the BFSI space, this is a thematic that is, utilizing AI extensively. No retail chain works without a recommender engine. If we talk about supply chain, demand forecasting and inventory management, these are utilizing AI. And of course, there are many other use cases in healthcare for cancer detection, for essentially wherever we essentially talk about delivering better experience to customers, today AI is coming to the rescue. So let me share with you some of the customer success stories. So if we talk about FedEx wanted to deliver a better customer experience. And for that, essentially, what they wanted to do is to be able to give more accurate information to the customers in regards to when their packages will arrive. And so they adopted Azure machine learning platform to really make use of the historical data, train machine learning models. And with that, they see phenomenal increase in customer satisfaction. They are able to really kind of share with the customers very accurate insights about when they should be really receiving their package. Similarly, BMW, now they have a lot of robots and they wanted to optimize the entire process for achieving better quality. So again, they utilize Azure machine learning platform to be able to essentially streamline, optimize the entire process and really embark on a mechanism by which they could incrementally increase the quality while ensuring the expectation, they meet the expectation that their customers demand. Now, talking about Carhartt, now they had a similar scenario wherein they wanted to really be able to deliver on to customer expectations, and so they utilized machine learning to come up with the right locations for opening new stores. So for this, they essentially analyzed many data points related to geographic locations, historical sales, the economic aspects of those geographic locations, and utilizing all this information, they were then able to zero in on the right location for opening the scales. And when they opened the stores, the revenue in those stores actually exceeded the expectations by 200%. So these are some of the case studies wherein we see that the customers employed Azure machine learning platform to their benefit. And with that, let me actually take you through a couple demos wherein you can see it all in action. And so for that, let me share my screen. Okay, so that just sorry, I have just too many windows open. Just give me a minute. Yeah, right. So I'm assuming everyone will have access to Azure, basically machine learning. They would have a subscription there, and if you have a subscription, um, you can create a new resource. So when you go to create a new resource, you can click on the AI and machine learning category, and there you would see something like machine learning. So you can click there, and once you create a resource, so it is fairly simple. Creating this resource is very simple. So as you click this, it'll really bring up the window wherein you can specify the resource group, you can specify the region in which you want to create it. You can specify various other aspects that you want to kind of basis your expectations. So like if you want a private endpoint or a public endpoint, and if you want essentially data encryption to be available, so you can essentially specify the settings related to data encryption. And after that, as you create, you will get a Azure machine learning resource, which will look something like this, right? So this is essentially the overview, and in a few minutes this will be up and running. And the key thing that you will essentially need here is, yeah, after that you can just click on Launch Studio, and once you do Launch Studio, you will be able to see a screen like this, right? So as you see here, you have all these different kinds of experiences depending on your need. So you can utilize automated ML, you can make use of designer experience or notebooks, depending on your preference. And then um, the great thing is you can manage all of your assets, so be it your data stores or your compute or your various environments. And what I mean by environment is like, you might be working with an XGBoost environment on a certain version of Ubuntu, or you might be wanting to work with TensorFlow. So you have these pre-built environments. So essentially, you get this central place wherein you can see what models you have, right? What models are deployed and what are their endpoints. You don't need to ask any of the people in your organization, because the entire information is available in a central repository, making it very, very easy for you to collaborate. Right. So let's get started, right? So typically when we talk about machine learning, we essentially talk about data. So let us say I were to really work with a certain file, and what I can do is I can say, okay, I want to create a data set, and for that, all I do is click on a data set, and let's say I give it a name. So let's say I want to create a credit rating model. So I give it, let's say, a name, credit rating data. And I say this is my tabular data set. And then I essentially click on next, and then I browse to this file, right? So let us see if I have some file here. So let me see what files I'm having in, like, on my machine as of now. So okay, so I do have some kind of some credit rating data. I see, I'll select that. So this is a file that I have on my local machine. And then I select this and I upload this. So now the model is actually going to be, the file is going to be uploaded. And it is going to show me a preview of the file. So I get to see the preview and I click on next. And now I have a data set, right? So now once I have the data set, as I click on it, I see that this is the data. Now this is not making too much sense to me. Okay. Now the magic is, as I upload this data, the platform actually creates a lot of visualizations that really makes it very easy for me to understand the data that I have. So like in this case, I see that the people who are a part of this data set, their age is ranging from a minimum of 17 to a maximum of 94. There are no missing values in my data set. Maximum people are in the range of 32 to 40. And if I talk about like job, I can see maximum people are performing admin job. And so essentially now this is super helpful, right? I can really understand my data without investing any effort at all, right? So now the next step is, yeah, I want to highlight one more thing. So here I basically created data set from local machine, but typically we will have our data on the cloud because we deal with massive amounts of data. And from the perspective of elasticity, scalability, we will typically have this data in Azure Data Lake or in a SQL database or Postgre or MySQL, and we can consume the data right from these sources, right? So that is about getting the data onto the platform. Next, what we can do is, let us say I have this credit rating data, which has historical information about whether or not a person, had good rating. And it could also mean like whether or not person was able to make timely payments to, let's say, credit card bills or loans, etc. And so now we want to train a model, and when a new customer comes to the bank, let's say, wants to be able to quickly figure out the credit rating of the person. So for that, we can utilize automated ML. And once we do that, what will happen is this platform will actually train these many, many models as we were seeing here. So it will train all these models for us. It will tell us which model is giving what accuracy. And it will tell us the hyperparameters, what features were created, etc. And let me show you how simple this entire process is. So all we do is we, click on a new automated ML run. We select the data source. So we'll select the data source that we just selected, we just created. And then it is, the platform essentially asks us to give this name for that experiment. So I can say it is a credit rating experiment. Now, because it is supervised learning, we will need a label column. So in this case, Y is the column which is having this information, whether the person defaulted on the loan or not. We select a compute cluster. So in this case, I have created a compute cluster by the name of GitHub cluster. And that's pretty much it. And then we say next. And this is a classification problem. And basically, the platform looked at the data and figured out that this is a classification problem. If I want, I can change or select some of the settings. So let us say if I did not want a certain feature to be included, I can basically say, okay, I don't want to include this particular feature. Or if I wanted to specify that a certain feature is of a certain type, I can specify that. If there are missing values, there is a certain way in which I want to handle the missing values, I can take that decision here. Of course, if I want to go with the defaults, I can do that as well. The certain other settings. So when we train models, there can be several metrics that we might want to focus on. Accuracy may not be the metrics that we want the model to focus on all the time. So we have these couple options which we can utilize. We can essentially, specify like we don't want a certain model type to be used. So we can, say that I don't want to work with the SGD model. I can specify what is my exit criteria. So like in order to optimize on compute, I can say that I don't want to train the model beyond like, let's say 6 hours, so on and so forth. Right, so I can specify this, but if I don't want to, I want to go with the default settings. That is something that I can go with. And so then I say finish, and that's it. Now with this, it will essentially train all these many, many models that we saw earlier. And we will be able to essentially, basically get interesting insights about those models, including how the model was performing. Right, and we'll talk about more about this in the responsible AI thematic. So basically, once the model is trained, we will, have all these various algorithms. So we can see that for XG Boost, I got an accuracy of 0.91. And actually, there were like more than 50 models trained here. And the worst performing model gave me an accuracy of 0.78. And the best performing model gave me an accuracy of 0.90. And after the models are trained, I can select any model here. So I can select, let's say, this particular model, and then deploy the model, right? So it is as simple as that. And so I can give my deployment a name, my deployment, let's say, and then I can specify whether I want to deploy it on Kubernetes or container. And then I can essentially just specify the settings, and then just say deploy. And once I do, similarly, I could have selected a Kubernetes cluster here, and I could have deployed it to a Kubernetes cluster. Now traditionally, you can imagine how time consuming and it is to really deploy these models, right? There is typically a separate team who does this for us, whereas in this case, the data scientist can himself or herself deploy the model. So once the model is deployed, we get an endpoint, and it is visible in this section. So all the endpoints are visible here. And yeah, so we get this endpoint. You see here, there is this test tab. And with the test tab, this deployed model, we can quickly test it. Right. So here I can give the values, and I want to show you something very interesting here. So here we see that this particular model was actually was getting influenced maximum by this duration feature. So let's see what happens if we give, let us say, some value, to duration. Some, let's say, we give some high value to duration. Does this prediction actually change? Because yes, it does, and that is aligned with our expectations, because we saw that duration was having a very high impact on the way model was basically making the predictions. And then further, to make things very easy, you get these code snippets. If in order for you to consume the model, you get this code right here, so you can just copy paste and make use of this deployed model to really incorporate wherever you want in your application. So you can imagine how easy the platform actually makes it for you. So just give me a quick check on the time. So it's 11, and I guess I'll take 10 more minutes on this topic, and then we'll move on to the speed side of things. So want to show you a few more interesting aspects of automated ML. When we train the models, the platform actually takes care of various aspects. Like if you're dealing with a classification problem, what if the classes are imbalanced, right? So it checks for that, and it gives you that information in the data guardrail section. Right. So, for example, here it is telling you that there were no imbalanced classes. Similarly, if there were missing features, it will tell you what were the missing feature values, and or rather, if there was a feature wherein too many values were missing, then it will tell you that these were the features, and so they have been handled. Similarly, if there were certain features wherein the cardinality was very high, it will give you that information. So in this case, in credit rating, there was no such things. But if you talk about, if I'll show you another example, this is the famous Titanic example, which any data scientist will bump into if they start on their journey on Kaggle. So here, what it shows is that yes, there were missing features, and if we look at what were those, we see that in age there were 177 columns that were missing values. Then there was this field embark wherein two features were two rows were missing values, and for each, the imputation that has been used is mean. Similarly, if we look at the high cardinality, let's see what it says. So it says passenger ID. Definitely, passenger ID should not be used as a feature, and so it is telling us that passenger ID was a high cardinality feature that was encountered. So, yeah. Sorry, there is a little disturbance. If yeah, if, yeah.
Yeah, I'm muting Shikha. Don't worry. I'm
Yeah.
muting them. Yeah. Thanks.
Then moving on, it tells you basically how the data was transformed, right? So, for example, in this case, we can see that this particular column, this passenger ID column, this was hashed, and then we have five columns that were categorical. Two columns were ignored. They were text columns, and we created these TF-IDF features for it. We created label encoder for these categorical columns, count factorizer for few other categorical columns. And for these, numeric columns, we for one column, we utilized mean imputer. So we can get all these different insights. Now, in logs, we can see the featureization summary. So we can really see what exactly was done, which columns were dropped, which columns were imputed. And we can also see the engineered feature names here. So like these are the various features that were created, and these are the names. So we can essentially see how the model is behaving, right? So while it is doing all of this in the background, we can understand how the model is really behaving. And then we can see what are the hyperparameters. So, like in this case, we can see for XGBoost, these are the hyperparameters that gave the model this amazing accuracy. So, if we were to really train this model in our notebook, we know what hyperparameters we need, and we can quickly get started with it. So these are some of the insights that I kind of wanted to show with you. Of course, I want to highlight one more thing, that we can utilize automated ML in Jupyter notebooks also. So here, like I have this particular notebook wherein I'm training this model, and I'm executing an automated ML run from my notebook, and then with this little amount of code, I'm actually able to get all the insights about various hyperparameters. So like for standard scalar, what was essentially the hyperparameters used, what like for XGBoost, what were the different parameters, so on and so forth. So it that way it becomes a very powerful tool at our disposal. So we essentially focus on the business problem, we hand the rest to the platform does all the the mundane work, trains it on different algorithms, different parameters, and gives us all the insights, so that we can really work very very efficiently. The second experience that I want to share with you is Designer. So if we click on this Designer tool here, it gives us this view, and here there are pre-built experiences. These demos, existing kind of designer pipelines, and so we can select any of this. So let's say if I select binary classification customer relationship prediction, right? If I select that, then it gives me, a pipeline that I can then, work with if my scenario is aligned with it. So let me show you how, this really simplifies and at the same time gives us flexibility. So let us say I wanted to really train customer churn model, and that's why it's called customer relationship prediction. So I had my data set. So now I clean my data set. And so basically I kind of get started with training with picking my data set. And if I wanted to pick any other data set, I could just drag it and get it here, and then join that to the next step. And then I clean my missing data, and here I can also specify how I want to clean my data, right? So I can specify where parameters. So like if the missing values fall into this ratio, right? And then what is the mechanism that I want to really use for handling my missing values? So that way is now I'm having greater flexibility here. Here I have two data sets that I'm using. This is the CRM data set, and this is the label. So here I clean my data, and then I join the columns from these two data sets, right, without writing any code. And then once I join, I split my data into training and test sets. And what I see here is that the classes are imbalanced. So what I do is I train an XG boost decision tree, a boosted decision tree on this imbalanced data. Also, I basically use the smart functionality to really handle this imbalanced data, and then train the model. And then I evaluate both the models. And once I devise this pipeline, I can submit it, and then it will run it for me, and then I will be able to visualize the results. So I mean, I have here a lot more flexibilities. So like if I wanted to transform my data in the sense that I wanted to let's say handle missing values or detect outliers and clip the outliers. So there are many options available to us, and we can basically utilize this and play with this. And of course, iterate. Data science is all about iterating, and so we can essentially work with many use cases here in this a very cool environment. And finally we have this notebook experiences. So I mean, again, the good part is we have a lot of samples here. So if I wanted to train like a forecasting model, forecast energy demand, I have a sample notebook here. I can quickly get started. So pretty much for any scenario, for like a text DNN model or credit card fraud detection, I have these lots of sample notebooks which can quickly help me get started on my journey and build this cool solutions. So with that, I'll take a pause and just check with Sandeep if there were any queries that would we would want to kind of bring to the fore before moving on to next section.
Perfect. I think Shikha, I've shared the links to tutorials. I think the question they have is in terms of can you share the tutorial again? I'll probably post the automated ML designer tutorial separately, and that should be okay. The notebooks, I think one question came up is, the notebooks that you showed, can they be reference shared outside of this environment? Right? That's the question. You might want to just address that. Otherwise, I'll drop the tutorials right away here.
Absolutely. So, great question. So, if we talk about notebooks, typically the way you can work. So, let us say if you're using Visual Studio Code or you're using PyCharm or using Jupyter Notebooks, and you're utilizing, let's say, GitHub as a source code for all this as a repository for all that source code, you can continue to use all those tools, right? And as you work with those tools, you have plugins available by which you can submit your training runs onto your Azure machine learning platform, utilizing the compute out there, utilizing this entire central repository wherein the trained models will be deployed, the endpoints will be created, while your source code will continue to be in GitHub or your preferred location. So yes, absolutely, you can really work with these notebooks outside of this environment as well.
Perfect.
So
We're
with
good
that,
to the next one. Yeah.
I'll move on to the next topic. which is speech. Yeah, so I'm sharing my presentation for that. Um, and as I basically share that presentation, talking about speech, it really falls in the realm of cognitive APIs, right? Um, so if we look at so as I mentioned earlier, right, we have a set of cognitive APIs. Just give me a minute. I am not sure if I shared the right presentation. Yeah. Right. So
Shikha, there's one question. One question you might want to take that. The
yeah.
question is, can we add custom models to Auto ML, or should we only work with what the studio provides?
Sorry. So when we talk about custom models, um, these are really custom models, right? When we talk about automated ML, we are building our custom models. Now automated ML is essentially giving you a mechanism by which you can focus on the business aspects. You can offload the algorithm, the hyper tuning, the hyperparameters tuning to automated ML. So yes, absolutely, it is for custom model training that you would work with automated ML. Right. So, talking about cognitive services, as I was mentioning earlier, what Microsoft has essentially done is that we have exposed all this, extensive research that we have been doing over last so many years in the field of computer vision, NLP, speech, and decision making. And now they are available to us as pre-trained models. They can, of course, be customized. We can deploy them anywhere, be it on-prem, cloud, containers, at the edge. And without any prior ML experience, you can pretty much, infuse intelligence in a variety of use cases, while at the same time taking care of the responsible AI aspects. So they form in the realm of language, vision, decision, and speech. In This session is going to be focused on speech. And when we talk about speech, there are essentially four categories. So we can use these models to convert speech to text, or to convert text to speech, or to translate from one language to another, or for speaker identification. So, with these, if we look at speech to text, you have many scenarios wherein you have multiple options. So you can use the base models, or you train your custom models. You get a spot for many languages. You can do real time transcription, or you can do it in batch mode. Similarly, if we talk about text to speech, you have the option for using standard speech or neural speech. So neural speech is very close to human like speech. It's very difficult to really make out whether it is a generated voice, or an actual voice. And again, you can custom train these models. Similarly, speaker recognition can be used for identifying a speaker or speaker verification. And then, of course, we can use speech translation for real-time translation and language detection as well. We have this, the speech functionality available in 100 plus locales. And want to highlight that Microsoft is investing continually in the improvement of these models. So we are continually deploying this functionality and more languages, incorporating enhanced features. And yeah, we work with the customers to take in their feedback and make sure that we deliver onto their expectations. Of course, we have rest of the ecosystem by which we can actually help in building end to end solutions, right? So that is essentially part of our feature set. So if we look at some of the like the features that we have available here, so we can get information about word level timestamp. So like when a certain word was spoken, and this is very helpful when we are actually trying to analyze a conversation. That gives us the an idea about how fast I was speaking, and that in turn translates to how well what I was speaking was being understood. So I can get timestamps. I can mask, profane information. I can actually if I was using batch mode, I can actually do diarization, which means I can essentially separate out if there are multiple speakers. I can actually separate out the text spoken by different speakers. I can, and then we have further downstream capabilities by which we can extract keywords, and we can perform other language understanding operations. Now, we as Microsoft, I mean, there are certain, differentiators because of which we essentially become the preferred choice for a lot of organization. And so the first is like, even though these are pre-built solutions, there is a mechanism to custom train these models to suit their, your needs. So, and then, we give solutions by which they can be hosted on-prem in containers to take care of your security and regulatory compliance needs, or in cloud. We provide telephonic capability, so you can essentially have a real-time integration to your phone systems as well as offline, and we definitely make sure that the entire solution is in conformance to the regulatory compliance needs. Just to talk about very briefly about some of the use cases. So, talking about speech to text, right? There are many scenarios wherein we want to really transcribe the call and analyze it. So, there are a lot of scenarios wherein customers interact with the agents, and we want to really analyze the conversation to make sure uh, that we are delivering the right experience to the customers and really improve on their experience. Then there could be a lot of multimedia content, and to take care of accessibility needs, we want to, let's say, provide captioning, or we want to basically, let's say, provide a mechanism by which we want to be able to search this multimedia library, so we can make use of that. Now, for speech translation, definitely there are many scenarios today with customer centricity at the center stage. We want to cater to different people speaking different language. So, if there could be an app, there could be a web application, and what we want to be able to do today is that rather than writing in a certain language, today we want to enable the customer so that they can actually speak to their device in the language of their preferred choice, and their speech translation comes in very handy. For text to speech, if we are building like a bot solution or any other conversational AI solution, if we are creating any kind of advertisement, then text to speech comes in handy. Now, talking about text to speech in particular, we have it available in 75, 77 voices, 49 languages, and this figure is actually evolving continuously because, as I mentioned earlier, we are investing continually to increase the landscape of our offering. We have rich SDK in multiple languages by which you can work with these. We have a web portal that essentially lets you work with this as you custom train and as you essentially and I'll give you a demo wherein if you have a certain text, you can actually convert into a speech with a tone, with a the choice of voice that you want, and utilize in your solutions. And talking about neural noise voice, again, it is available in many languages. Um, um, and you can of course build custom neural train solutions also. Now, giving you talking about neural voice, it is essentially, gives you very high parity with human-like voice. It becomes very difficult to figure out if it is a bot speaking or a human speaking. And further, if you're custom training the model, you can actually custom train it with very few samples compared to traditional, text, uh, text to speech models. So just to give you some examples, um, I'm just going to play an audio here. So this was, just one kind of audio that I played from in the Hindi
Shikha,
language. Yeah,
Shikha, I don't think we heard audio. You might probably have to include audio when you share
sure,
the screen.
sure. Thanks for that. So yeah, I will probably try to see if I can include that now.
Otherwise, best reshare it.
Yeah, just gonna do that. I will. I'm just.
Shikha, while sharing it, you might want to include the computer sound. It will be right on the right hand side while sharing the content.
Absolutely. Thank you so much. Let me attempt to do that. Yeah. So I am now trying to share my presentation with, the sound enabled. My apologies. I did not do that earlier. And right. Yes. This is. So was it audible now?
No, play it once again, Shikha. Let's see. No, not able to hear anything.
Okay, no issues. No
Good.
issues. Yeah. So I'll move forward. Um, So basically, with this, we can, as I mentioned, we can basically train custom neural voice models as well with a very small amount of data to take care of any, specific needs that we have. And it is the process is very simple if we were to train like a custom speech model. So what we do is we essentially first generate the data, and for that again we as Microsoft provide tools so that you can generate the training data. You upload the training data onto a custom training portal, and you train your model. You can evaluate your model there, and then you can deploy it. So we basically provide all the tools to make this entire experience very easy. And I will take you through a couple demos there. And yeah, so there are many scenarios, which, and I'll shortly share a few customer stories there. So of course, just want to highlight, we take care of the entire security aspects, the privacy aspects. So with container deployments, you can be assured that the data does not traverse outside the boundary of your premises. The entire transcription, translation happens within, the boundaries. And the entire solution can be very scalable depending on your needs. So you can essentially make use of fast batch scheduling, elastic scale, and several features are available so that you can have the concurrency and the scalability that you need. In terms of delivering the models, you can deploy them on prem containers, you can deploy them on cloud, and of course we have rich SDK both for devices for your microphone array hardware as well as for Azure speech to build these solutions. With that, you basically, are able to make a choice whether you want to work on cloud or on prem, right? So typically, when you would go on cloud is when you're looking forward to, easy scalability, easy maintenance, reliability, right? And to be kind of to leave the compliance aspects to the cloud. And on-prem, let's say if you have extreme data traveling legal compliance scenarios, then you can very well deploy them on-prem. And if there is, let's say, an internet connectivity issue, that is another scenario wherein you would want to possibly deploy the solution on-prem. There could be different scenarios, real time as well as batch processing. And so there is a specific batch processing kit, and batch processing has a larger number of features also. So, for example, diarization is available in batch processing, right? So that is in terms of the languages that we support: C Sharp, C++, Python, JavaScript. These are multiple languages in which the SDKs are available. If we talk about some of the use cases, right? So from accessibility perspective, like for generating captions, so there could be video recordings, there could be live records, live events, and so we can generate captions. For conversation transcription, we can basically use this. Different, we can even use this for dictation. So there are many accessibility scenarios wherein we can provide interesting functionalities to cater to customers of various needs. And for if we talk about like call center scenarios, we can analyze, we can extract key thematics from the conversations. We can display them as word clouds using the downstream capabilities. We can extract sentiments and so on and so forth. So, there are many scenarios in which this solution is being utilized heavily in call centers for a process evaluation, for product sentiment evaluation, for employee evaluation, and even for understanding costs. So in cost centers, we want to know where we are investing, where the major conversations are happening, how many calls are happening, what people are saying about our products, and all these insights we can essentially unlock by using these solutions. So with that, let me actually, share my screen for some of the demos. Um, and let me really, yeah. So again, in order to get started with it, it is very simple. You select the speech resource in Azure Machine Learning portal. And when you create this resource, you will be able to see something like this. And the important thing that you will need is, the keys and endpoints. So essentially, these keys and endpoints are what you would need as you work with your with the language of your choice to create solutions. We have extensive documentation to make the journey very easy for you. So let me kind of share with you how easy it is to work with speech. So once you specify your key and your and the region in which you have created your basically service, your resource, then you can instantiate your speech resource. The first thing that we are trying to do is convert speech to text. And so in this case, we specify the language in which we will be working. So the language is the first demo I want to show you is going to be utilizing Hindi language. So once I execute this, um, here what I'm saying is that I want to read, basically listen to my microphone. So for that, let me basically speak something to my computer, and let's see how it converts. आज बहुत अच्छा दिन है. हम एक बहुत ही दुर्लभ डेटा साइंस कम्युनिटी के साथ एक बहुत ही इंटरेस्टिंग कन्वर्सेशन कर रहे हैं. Sorry, let me speak again. आज बहुत ही अच्छा दिन है. हम एक बहुत ही दुर्लभ डेटा साइंस कम्युनिटी के साथ एक बहुत ही इंटरेस्टिंग कन्वर्सेशन कर रहे हैं. Sorry about this.
Yeah, Shikha, basically, probably looks like there might be something issue with the mic because earlier you couldn't share the audio out for us. Just check once again. Should be okay.
Sure.
Or if it doesn't work now, no, when after my talk, you can probably fix that and come back
Sure,
later on.
absolutely. Let me try again. That's a good point, Sandeep. आज बहुत अच्छा दिन है. Very interesting. This is the standard demo, not working. Okay.
Yeah, it happened. That's fine.
Should you run it and check? Because
Yeah, let me just try a very last time. Um,
Yeah, I mean, Shikha does this day in and day out. So it's strange. It's not working. It's
आज
just
बहुत अच्छा दिन. Oh, for some reason. आज बहुत अच्छा दिन है. हाँ. For some reason, I'm sorry about this. This is not working. Um, while I tried it in the morning, it was working. So no issues there. But you essentially what I will try to do is show you another, try to work with another demo here. To, Okay, so let's try it the other way around. Let's convert an audio file to text. Okay. So here I have this text. I had a very delightful experience at the service center today. The staff was very polite and everything was done in a very timely manner. And sure. Okay. All right. So that is quite interesting. So let me do this. Let me show you our portal from where we can. Sandeep, is there any possibility you could show demos? I know you are not ready with it.
um, I don't have that option, Shikha.
Sure,
That's okay.
sure.
You know what? After I finish, you can come back. That should be fine.
Sure, absolutely. Yeah. So, right. So let me show you a Speech Studio. Now, in Speech Studio, what you can essentially do is you can train custom models, right? So here I have uploaded some data. And here essentially, the basically I after uploading the data, I can click on train custom models and then test out these models. And for creating the data, in Speech Studio itself, I can upload the file. I can basically, create a text file here. And so let's say I create certain text here. Um, Today is an interesting day, right? And then I can play this file, right? So, okay. And I have multiple options here. So I can change the pitch, I can select the speaker, right? And so basically I can work with these different options to kind of work with this. So we have all these various tools available by which we can, work with this thing. So I can play this file here, and okay. So here, like I can select various voice here.
Today is an interesting day.
Now, if I wanted to play with a different, Sandeep, was that audible?
Yes, it was. It came
Okay.
up. Yeah, yeah.
Okay, so now I can select if I wanted to basically have another voice there, I can select that voice and then today is an interesting day. Now I can change, the pitch, etc. And depending on that, the audio will actually change. Today and is an interesting day. And then I can save it, right? I can give it some name and I can save this file. And now I will have this repository of audio files available here. And so this is how I can easily create my training data, which I can then use for training my models. So that this way, I can essentially work with a number of scenarios, convert text to speech, speech to text, translate from one language to another, and essentially create these innovative solutions. So, any questions here, Sandeep?
I think we're good so far, Shikha. I think whatever questions they had, some were earlier on, automails have answered them. Yeah, try your first demo once again. I think it's probably Teams. In Teams, see which microphone is selected. That's also is that also matters because right now, for the demo, it was audio is working.
Sure.
Just check your Teams on the mic, and if it's same as your system, should work. Pratham,
Right.
thanks for that. I think yeah.
Right. Let me kind of try this. Funny thing is definitely something weird.
Yeah. Yeah, and for folk listening to us, it's a demo that she does every day. This is not a day. That's it.
आज बहुत अच्छा दिन है. So, Sandeep, there is a problem. I'll work with this and maybe uh,
Good,
if in
good.
the next session, by the next session, I'm able to get it to work, I'll show that.
That's perfect fine.
Oh,
Yeah.
I got the problem. I'm sorry about this. I can see the problem.
Oh, there's something else you've done?
आज बहुत अच्छा दिन है. So,
Wonderful.
yeah, so I wanted to, I had reset the variables. I didn't realize that. So now I can show the demos, and that's really nice. Thanks for giving me an opportunity to try again. Okay, so now let me show you all these things in action. So here, after we specify the language and the key and the region in which we have deployed our resource, it is as simple as giving this API call. Okay. And basically, I will speak into the microphone and then it will convert. And interesting thing is, I can speak a mix of Hindi and English, which is what we typically do, right? English is our standard language. So let me try with one more example. आज एक बहुत ही अच्छा दिन है. हम एक बहुत ही दुर्लभ डेटा साइंस कम्युनिटी के साथ एक बहुत इंटरेस्टिंग कन्वर्सेशन में पार्टिसिपेट कर रहे हैं. So you see, it has been able to kind of convert this very accurately. Right. Similarly, I can do it in any of these languages. And as we could see, there are, around 100 language in which this functionality is available. So let's try it in English. Today is a wonderful day. We are having an interesting conversation with the esteemed data science community. Right. So, it has been able to convert that. Similarly, we can convert text to speech. So let us say I had this text. I had a very delightful experience at the service center today. The staff was very polite and everything was done in a very timely manner. And so let's say I wanted to kind of convert this into audio.
I had a very delightful experience at the service center today. The staff was very polite and everything was done in a very timely manner.
Right now, this kind of conversation, this, I mean, you can imagine the possibilities that we have with this, right? I mean, we can actually make the entire bot communication driven by speech, or our apps, or our web applications. We can incorporate this voice capability into our solutions. We can engage in human like conversations in our IVR solutions, and extract meaningful insights from all of that. So just to give you an example, like this audio file that I generated, I can then perform downstream task, which is like sentiment analysis, and inform. So here what I'm basically doing is making use of this test.wave file, which we just generated here, and then performing sentiment analysis on top of that. Now, so this tells me it is a positive conversation. And then I can then plug it on to my teams. So here, this is what I'm doing. Now, I'm getting, I can inform the stakeholders that, this conversation was positive, and, if any action has to be taken, we can take that right away. Maybe a senior manager needs to come in and do something. Or if the conversation was negative and we wanted to take some action. So basically, we can build an end-to-end real-time solution wherein as the conversations are happening, we can extract insights from those. Similarly, we can convert from one language to another. So like if I wanted to convert from English to Hindi, we can utilize the translation API. So taking this service example, um, my bike was serviced My bike was serviced very well today. So it translated it in Hindi. आज मेरी बाइक की सर्विस बहुत अच्छी तरह से की गई थी. So so these are just some small samples, some small demos to share with you insights about how easy it is to work with these APIs and create these very powerful solutions. So with that, I'll take a pause and see if there are any questions that maybe I need to handle. I'm sure Sandeep would have taken care of all of them.
Yeah, no, I think there's one last. I think, can English words be recognized in the English accent? Of course, answer is yes.
Yeah.
And displayed in English itself.
Um, so yes, so with a certain, of course, custom work out there, you will be able to accomplish what you are aiming for. Yeah, it is definitely at this point of time, it is not an inbuilt capability, but definitely it can be accomplished.
Awesome. Cool. Translate from speech to speech as well. What are the questions? I mean, there's a question. Is it possible to translate from speech to speech? Yeah, I mean, you're talking about, let's say I'm speaking Hindi, it should be spelled in English. Yeah, I mean, there is a process for that.
Having to convert to text. Can that be done?
Absolutely. So So essentially, as you speak, you can, I mean, you can convert it into another language, and then you have with text to speech, speech to text, you can pretty much do whatever you want to do, right? You can apply those permutations and combinations to get the end outcome.
Yeah. No, by the way, I think the question is interesting. You're saying without converting in text, can you convert from English to Hindi? Right. So first of all, machine need to understand it. So that's where STT happens. Then you do the TTS, right? But for somebody who is watching, listening, it's straightforward. It's seamless, right? Cool. I think it's time for break. 11:50. We took slightly more time, which is good. I think good questions, by the way. Why don't we do this? We started at 10 o'clock, so 90 minutes done. So we'll take the first break. Probably may not need another break because we will keep it conversational. Whenever you want to break, just go and come back. But we'll just do a 5-minute break. Is that okay? 49 right now. Let's resume at 55. Yeah. You want to just grab a quick coffee, water, bio break, and let's resume. And I'm going to take you through in a couple of two more capsules. Shikha, kind of address two, and I'll take you to a couple of more. We'll start with vision, dominantly document processing, and then we'll switch to semantic search. Yeah. So 5 minutes break, 55 will resume. Shikha, thank you so much. I think finally all the demos work, which is good. It's a magic of one line of code which was blocking your audios. Glad you recognize that.
Thanks. Thank you so much. Yes, it definitely feels good.
No, I was wondering because you do this every day and probably you've done some extra coding there. So awesome. Okay, I think we'll get started. Yeah, so welcome back. Just checking. Most of you should be back. And a quick yes on the chat window will do. Just say yes, and I would know that you're back and we can get started. Yeah. Yeah, somebody has a question. Your question was speech in Teams and Zoom, so you can just look at a capability called Azure Communication Services. The entire infrastructure is available there. Thanks, guys. Thanks so much for your quick guesses, and we'll just get going right away. First things first, some of you were asking question about ML Studio, right? Automated machine learning that Shikha showcased. That's one for sure, but there's also another ML Studio where it's called the Designer, which is what Shikha showed in terms of drag and drop. There is a classic model available, and if you go to the studio.azureml.net, and there is a sign up button here. If you click on that, right, so you actually get a free evaluation workspace. You can just try it out. No sign in required there. You can just play around with it. Yeah, I thought I'll just showcase that. Okay, so with that, let's get going right away. See, if you go to Azure portal, right, and if you look at the cognitive services, let me just bring in Zoom here. I'm just going to get magnifier so that you guys can see it clearly. Just give me a second. Magnifier comes up. Okay. Second. I should have loaded this before. Okay. So if you look at my screen right now, yes, you have cognitive across speech, language, vision, decision, OpenAI. So right now, we'll focus on vision, which is where the next 30 minutes will invest. And of course, what you saw earlier from Shikha was speech and bit of language there. So now, vision, all of us understand, right, in terms of face recognition and computer vision and whatnot. So our focus here will be document processing. I think that's one thing which is probably a dire need in industry in terms of ability for us to apply technology to process large corpus of document data, right? But of course, there are two things here. One is, of course, cognitive services, which I'm showing. There's also applied AI, which comes in the form of form recognizer, and I'll show that in a little while from now. But let's look at some real use cases here, right? I'm going to take you through one couple of use cases, right? So I'm sure some of you may be working in BFSI industry or any other industry where there's a need for you to look at how you can process documents using vision capabilities. Now, this is a quick example I'm showing right now. Let's look at a standard example of KYC, right? So what we'll do is we'll look at what are the use case, how technology is going to help us solve that. Then we'll go through a short tutorial in terms of how you can go ahead and build something of your own, and eventually a couple of more demos. Yeah. Now, if you look at, and again, right through my talk, feel free to post your questions. Shikha is there looking at the chat window. She'll answer that. And otherwise, we look at in the end as well, right? So we have a good amount of time in the end for Q&A. Now, okay, let's look at KYC. Yeah. Now, by the way, your question is, yes, we have driver's license, passports, Aadhaar cards, etc. So how do we ensure we can process them with no human intervention, right? Let's look at this. Now, I'm going to just open, by the way, we'll talk about what technology is powering this, but before that, we're just showing a few demos here, right? Now, Aadhaar card, the front side of the Aadhaar card, right? So we're basically loading some live cards here. And as you see there, the Aadhaar card comes up, and this card will be sent to a cognitive or applied AI service, which comes back with the data, right? Basically, you might get a JSON file back, right? That's something which your program will be able to process it one by one and get done with it, right? This is one example. Now, another classic example would be in the context of inking, right? Let's look at inking. Many times you'll have handwritten content, right? This is also one of the classic use case in the industry where documents having annotations being done on paper, signatures being done on paper, you got to verify it, right? So this is another example where you can with utmost accuracy, you're able to extract content from a check, which is handwritten, right? If you look at in the current banking and finance domain, now when you're availing a loan, right? So typically you have a big fat document booklet. They make you sign vertically and horizontally in each paper, right? There'll be 25, 30 page booklet you have to sign. But it's humanly impossible when somebody uploads a document to verify every page. That's where signature verification, all the stuff, absolutely doable using the power of OCR, right? So this is one last example before we kind of move into a quick walkthrough of how to do this. Now, look, so there is no end to the document. There might be rental agreement that you want to process, extract information from that. By the way, rental agreement, the format changes. How to deal with that? We'll get to address all of that, right? So most of the documents that you see here, the real documents, Indian local documents, and ability for us to extract information is absolutely possible today. Okay. That brings us to capability, which we call it form recognizer. Yeah. So let's jump right into just a couple of slides, and then we'll get into a quick demo on that. Okay. I'm just going to move this. Okay. Yeah. So now, if you look at form recognizer, this basically comes across as an applied AI service in Azure. Okay. Now, if you look at, there is definitely a general purpose OCR. That means, these are OCR models. You give an image or a document, it extracts text for you. But of course, you basically you don't control what happens. Much of what comes out is controlled by the model because it depends on how the model is trained. Now, this is where that's a general purpose OCR. But if you look at scenario specific, this is where we say this capability is truly a applied AI service. That means you're solving a very specific generic issue in the industry, and that's called the form recognizer. So when I say form recognizer, it's an OCR model again, but they're pre-built for specific scenarios. It can be invoice processing, it can be business card processing, it can be specific type of document of a specific country being country that you're processing, right? Again, the documents layout, all the existing document, how do you extract that meaningfully, right? That's what form recognizer as a capability does brilliantly for us, and that's something which we'll go through right away. Now, considering form recognizer, right? There are specific use cases here, right? So we'll go through the form recognizer studio in a bit, but ability for us to extract text which has a structure to it. So when it's a structure, that means there's a document, there's a structure to it. Hence, we're saying it's a specific business case you're going to solve. Then how do you extract content from the form? It can be form, which probably has a table, tabular, display, whatever it is. And ability for us to take this model. See, everything we're talking right now, we're showcasing the speech models, language models, and vision models here, which is text extraction. But deploying anywhere is end of the day if it's a bank, Indian bank, right? So basis the regulatory, they might say, you know what, I can't be making a cloud API call to process my millions of documents I get every single day, right? Reason one is latency. Number two, regulatory, right? They're bound by regulatory. Of course, you can actually make a cloud call in the country because, of course, the data centers are in the country. But to reduce latency, right? So they want to probably process in the back office data center that they have at the facility, right? So hence, ability for you to build these models, train in the cloud, which is what we'll see, eventually deploy to edge or any other environment where you want to process documents is expectation and hence a reality. Okay, so let's do this. By the way, while we're talking about form recognizer, there is also another cool capability when it comes to computer vision, which is again video analyzer. Just look at this example here, right? So using video analyzer that we have it as a service, again, applied as a service, you'll be able to identify specific objects, and you can also custom train this, right? So at the end of the day, if you look at use cases, workplace safety, this is an airline example, as you see here, where you're seeing some visuals here, where ability for us to pretty much identify, yes, it's aircraft, it's arrived at so and so time, it's on block, forward door open, left wing, etc. Right? Passengers started coming down, cargo, fueling, all the stuff will be able to pretty much identify. And this is the true power of when I say applied AI service, ability for the service to be very meaningful, contextual in terms of what use case you're solving is the reality. Okay. So let me just take a pause here and go back to the tutorial. Right. Let's get right into the tutorial and we'll take it from there. Okay. Any questions? Feel free to post them on the chat window. Okay. Now, where is my um, so I just want to let you know that the service I'm going to show right now is basically form written tutorial. I'm going to just put this link right into the chat window so that you know what I'm going through. That way, it's very clear to all of you. Okay, just take a look at this, and this is exactly what I'm going to go through. So, form recognizer labeling tool. Again, if you look at what we can do here, right? We will go through that in a bit. So by the way, you should know that there is something called Form Recognizer Studio. So I'm going to just jump right into that and show you some capabilities, right? So typically, when it comes to building a model, there are a few options you have that we give, right? We use a pre-built model to get data. When it's a pre-built model, as you see there, it can be invoices, right? Let's look at this. Invoices, receipts, business cards, and more, right? So these are pre-built model. That means invoice will have specific labeling done by default, right? I mean, we're talking about label data here. Otherwise, if you don't label data, nobody knows what data it is. So business cards have specific data in that stuff you can recognize looking at the content. Receipts also, right? It has the number and whatnot, etc. Right? So we look at three options right now. One is pre-built model to get data. Second, of course, is use layouts, right? So typically, if you look at these may not be pre-built model, but this again a pre-built model which will recognize layouts in your service, and even finally we can build a custom model, train it, eventually take and deploy it. Okay, let's look at pre-built model to get data. And just so that you know, guys, so I've already configured my project here with my form as an endpoint. The way you do this is you should go to the Azure portal. Let me just show you once, right? So let me just refresh it. My session is expired. Let's refresh it once again. So you need to go and create basically a form recognizer endpoint, or I would say cognitive service endpoint. So quickly, right? So most of the time for any cognitive API in the cloud, you eventually end up using a resource. Now you can create one resource, which basically is an umbrella resource. You can create something called, for example, if Shikha showed speech, Shikha showed, let's say, a language, etc. Now you end up creating a cognitive resource, right, for that specific cognitive API. But if you're using many cognitive APIs, you can go and create something called cognitive services multi-service account. You see this at the top. So this way, when you do that, cognitive multi-service account, that way, by using the endpoint of cognitive service and the API keys, you can call any cognitive API. You don't have to create specific um, specific resource. Yeah, that's what I've done here. Okay, so already configured here, which is where I can show you there is a endpoint and key. All the stuff has been saved here. Yeah, not to worry about that. Now, Let's look at specific scenarios. Okay, I'm going to use pre-built model. And again, if you look at pre-built model, the best part is I'm going to just zoom in once again. If you look at the form type here, right, it tells me, hey, what kind of a form you're trying to process, right? I have to be very, I have to know that, right? It's the random. It's not a random form, right? Because the reason why I'm saying it's not a random form is because you know what the document you're processing, and hence the model has to align to that. So otherwise, it becomes like a open-ended problem, which is a general purpose OCR will do. This is business specific OCR that we're talking about. So invoices, receipts, business cards, and ID. Yeah. Now, what I'll do is I have a few files locally, and let's start with invoice. Yeah. Let's with invoice. And by the way, I've already given my cognitive service endpoint, which is what is here. And you can don't copy this. Even if you copy, you can't do this because there is a API key for that. Okay. So now I'm going to just browse for a file, local file. There should be a demo folder with me. Yes. Let's look at invoice. I have a random invoice which I've got from internet. Right. This is a sample one. And let's look at when I run my analysis on this. That means I'm basically sending this document for cognitive form recognizer endpoint. And my request is, if you look at this particular stuff, right, this is the API request that we're making to the public cloud. Let me just zoom in on that, right? So this is exactly what we're doing. There's no the endpoint is not it's incomplete, but this is exactly a REST API call you're making, right, with the version, etc. Let's run analysis now. Yeah, analysis and the progress, and in a few seconds you should see the response coming back with a lot of bounded boxes on content here, right? As you see here, this is the best part, and I've got the lot of I would say content back, which is basically this is basically JSON response, right? You can actually download it here. You can download a JSON or a CSV at the top, right? But let's look at this, right? If you look at each, let me just zoom in a bit. Okay. Every single section within this particular invoice, it is extracted. Some of it, if you think it's not, that's when you get into custom model development. But let's look at this. If I just look at customer name, right? AB company, it's all right there, right? Invoice date, right? It's all there. So pretty much every single thing that one observes in invoice, this API is picked up, right? Of course, at times, if you're very particular about position, that's when you also get into custom training. But if you're looking at, let's say, total tax, it's all right there, 3459.90, right? Which is where total tax amount, I can just zoom in here with the stuff, you'll see 3459, right? This is what it is. Now, this is the beauty. This is, by the way, all we've done is, we've kind of chosen an invoice as a form type to be processed. There's no coding required here, and you just make API call, right? While I'm showing in a studio, it's a REST API call you can make by specifying endpoint on the key. Yeah. Interestingly, if you look at it, there's also something called there is a form that is extracted. I can click on this. It actually gives me a beautiful table, right? I mean, look. So end of the day, I have to navigate row-wise in my JSON and pick up specific attributes. So this is actually converted my entire document into a form. That way it's easy for me to go through one by one and pick it up. And this is the exact replica of what you see here, right? There's no difference. There's absolute difference in terms of how it is processed, right? You see solvent white cleaner industrial 345, 345, 23 is the preparation, all the stuff. It's absolutely there. Yeah, this is the first example. Now, as I said, it can be invoice, it can be receipt. Let's look at receipt for an example, right? Let's pick up a receipt, which probably again is interesting one here, right? It is again Indian receipt, PK fuel station in Mumbai. And here the form type I have to change it to receipt. That way, again, local I can say ENIN, right? And I can just say run analysis. Let's see what happens. I didn't do this yesterday, so let me see if I just downloaded the receipt. Hopefully some should work well. Absolutely. So as you see here, it picks up the merchant name, right? Merchant address, merchant phone number, total 78 INR, one lead. I don't know when this was done. 2017, no wonder, because that's not the petrol price right now. Right. So transaction date, transaction time. So these are specific things that you, by the way, this probably would not have been trained for. I mean, of course, we're saying English Indian, so that's where it looks like it's been trained for specific receipts targeting specific regions, right? And globally, you typically look at any invoice, any receipt, you'll have the date, invoice number, and all the stuff will be there. Of course, you go to gas station. This is a common entity that you see across. Yeah. So this is a quick example in terms of how easy it is for us to kind of run this across. Okay. Now the question is, hey, why I have documents coming in hundreds and thousands. How do I run this, right? So I have a simple example I can show right away for you. Now, if you look at this, yeah. Now, basically, whatever you saw there, and I just want to ensure the key is not visible. Now, basically, this is again in Jupyter Notebooks. I've spun off a compute in the cloud. I've just started my Python notebook. Now, basically, again, Azure.ai is the library import. You can just do pip install and form recognizer. I'm specifying invoice, right? So end of the day, I have to specify what kind of document I'm processing. So that's where the form recognizer client comes in handy. The invoice processing, there's a document which I've sent in. And let's run this for a second. Control enter. This is done. And so look, so basically, once I get the JSON response, right, polar or result invoices, I go to enumerate that and extract specific content there. Yeah. So let's run this and see what happens. Should come back with response very soon. Now, as I showed earlier, each of the document will come back with the bounded box, and my JSON response is what you're seeing right now. And this response basically also gives me a confidence score, right? In terms of, yes, invoice ID was extracted with the confidence of 0.97. So that way, if the confidence score is less than 75, I might not even consider that. I might say missing data, and that's where you tag it for human intervention. See, this is the reality. Today, when you're processing a document, and depending on the confidence score, you might set a threshold for a confidence score, saying if it is under 90, I mean, let's not have under 90, anything below 90, that means I will not read that. I will say unable to find, and I'll put it in red. That way, human intervention, when human intervention happens, they'll go to the document and they'll double check, right? By the way, I would read it and put it there, but I put it as a red mark saying I'm not sure because I'm less than 90 confidence score. Yeah, that's what it is. So this is as simple as that, right? The SDK is available whether you use Java, Python, PHP, C Sharp. So we give you SDK for every single cognitive that you've seen so far. While we're showing dominantly Python, but you can use choice of language to actually build them. Yeah. So let's go back. Now, this is scenario number one. Now, I said earlier, this is pre-built model, by the way, what I showed, right? Now, let's look at use layout to get text tables and selection marks, right? So end of the day, you want to use form recognizer layout service because you want to text from specific tables. Because imagine if your documents is largely tabular, and that's where you look at, and again, it may be an invoice, it may be receipt, it can be anything. That doesn't matter, right? This is where you want to extract table, and let's push one document sample. Let's go back here. Sorry. Um, this is, yeah, let's look at this. Um, right. This is my, okay. Let's run this and see what happens. Okay. So look, so this is what I meant earlier in terms of this can be random document I'm sending here. And this is when I say table, this is exactly what it comes across, right? This is basically a tabular extraction of data for the mobile number, the charges, blah, 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 right? And some of the documents where you're unsure of the overall layout, but you're sure there is a tabular display there. There's a layout specifically for your stuff. You can absolutely go ahead and use the service. Okay. Let's move forward. Now, this is the second one. Of course, if you look at the custom, if you look at, what, I don't have an invoice. I have probably an invoice, but I have a lot of additional text within the document, which probably is not run of the mill. It is an unusual document, but I want to ensure my model is trained with labels, which I want to extract, right? This is where it gets interesting. And this is where the true essence of the world-class models and transfer learning technique comes in handy. I'm sure all of you understand transfer learning. If not, just look it up. I'm going to just, by the way, you can start a new project. You can specify the connection string, right? I can put any display name, but basically, this is where you for you to build any model, right, you need to ensure you're using a form recognizer service. That's where the form recognizer URI comes into the picture. By the way, you see something called folder path. So basically, this is where I mean, you point your form recognizer to a blob storage where you uploaded probably, you know, documents required for training. And just so that you know, all you need is 5 documents minimum only for you to train this model to recognize additional labels that you want the model to recognize, right? So hence I said earlier transfer learning, because the bulk of the training is done. The delta addition is where we're going to just take the domain that already exists into building a new model. Okay, I've already done that, by the way, and hence I'm not going to do this. I'm going to cancel it. And if you see here, there's already a model which I load right away. These are, and I basically wanted to recognize total. Total in the bottom right is something which the form may be missing, right? Because it's here it may not miss it, but it's a very straightforward document. But just to give you perspective, it probably would not get recognized because of various reasons. It's a custom tag I have, so I want to ensure that get recognized. So typically, what to do is this is basically the labeling tool, right? Eventually, you'll have to instruct the model that, hey, this is the label I want to capture, and this is the value for it. Key value pair. See, bulk of what you do in the form recognizer is extract key value pairs, right? And that's where you enumerate through the response of the JSON and you extract data, right? But there are scenarios where the key value pairs are not clear to the model, and that's very specific to your business, and hence you want to bring in a custom model training here. So if you look at this document, basically, I need to define tags. I can absolutely add a new tag, and that new tag can be, let's call it as a sales. Let's call it as subtotal. Okay. Total is a new tag. Okay. I'm going to enter that. Now, by the way, when I say subtotal, I'll have to basically instruct what is subtotal there. Okay. For each document, right? For each document, I have to go and it runs a layout. I have to probably go and specify this is the subtotal. Yeah, this one, and click the subtotal. Right. It gets mapped. Right. For each document, I'll have to ensure the subtotal is basically uh, tagged, and I'm just tagging right now as we speak, right? This is a, as I said, you just have 5 documents, and by the way, we can do it automatically also, as long as you know the where the position of that is. You can absolutely write a simple Python program to, there is a something, there is a program in GitHub which does auto labeling for you, so you can do that also. And I'm just doing that right now. Select subtotal and subtotal, right? So once I've done that, basically, this is where I eventually trigger training, right? I basically have already done one model training. I'm going to just probably do another one, right? Earlier one gave 99.5% accuracy, so training new. Okay, I trained this, training in progress, because this one will recognize both subtotal and total for me, right? And once the training is done, I should be able to download the JSON file. Yeah, and if you basically want to use this in your API call, the model ID is what you need to remember, and then you should be able to make an API call. Yeah. So in fact, the one I showed earlier, right? For example, let's do this. Um, let's do a quick analyze, right? We've trained the model, right? So look, so model to analyze with. So I can change it because I have 2 models. Just now I trained training new, right? Training new is this yesterday's training, what I've done, custom model number 1. Training new is now, right? It should recognize subtotal also. Let me just apply that here. And let's look at a sample form here, right? Let's look at, see, this is the training 5 documents I use, invoices. I'm going to choose a test and just pick up invoice which I've not used for training purposes, right? So, and let me just do run analysis, and it should recognize in a few seconds the total and subtotal, right? 9450 and 8550. You see this here? I'm going to just zoom in a bit. So for you to basically build a custom model which recognizes and extracts content which is very private to business, which the generic model will not recognize. See, generic model may recognize every single entity on this form, right? Let's look at let's do this once again, right? I'm going to just use, let's say, pre-built or let's use layout data, and I'm going to just browse the same file just to give you a perspective in terms of, yes, the generic model dominantly will recognize majority, right? I'm not talking about every document you should go and look, right? So if you look at this is basically a layout, which is what it's come by. Let's look at invoice. This is the invoice, right? So let's look at the first custom model. It will actually recognize. What I'm trying to tell you here is the fact that many times you will have documents which basically the custom models which you're seeing right now may not recognize, right? So look here, it is recognized already here, right? If you look at the bottom, subtotal and total, it is recognized already, right? No big deal, right? Invoice total, which is 9450 and 58 is recognized already, right? But imagine you may have something which probably is out of regular, and that's where you get to the custom models, and that's where you get to define custom labels, and that's where you get to map custom labels to the key value pairs and train it in the cloud. As I said, the best part is most of the models. See, when it comes to applied AI services, there is a small window that we open for custom training, and that's where transfer learning comes into effect, right? The reason why the small window for training is because, yes, you'll have to optimize. It can be a speech model that Shikha showed. If you want to create a custom voice, if you want to train it for the vocabulary that you have in your industry, so all the stuff should be possible, right? And that's where this little training utility is handed off to you, and that's where you can actually customize uh, basis the highly accurate world-class model that's already there, using the power of that and training it for your benefit by supplying data which is private to you. Yeah. So I'll take a quick pause here. Any questions, any thoughts, anything that you guys have? Shikha, anything that has come up which should be addressed? Just checking.
Yes, Sandeep,
Yes,
there is.
Okay. So there is one, right? Um, Form OCR seems to extract ROIs from scanned document. If I have a screenshot of invoice document and shadow is also present in regions where text data is present, the service work in this scenario? See, here's the deal. Interesting question. Now we've seen customers try this out, and this is where your custom model comes in handy. By the way, I've said 5 documents here, right? Imagine, see, look at it this way. What would you do? How would you process the document? The question is not of questioning the mission, but which one would you consider if there is a shadow, and the shadow also have a replicated data of that, right? That means there is a duplicate data that's visible to the mission, and mission also gets confused, right? So now this is also a classic case where you want to do custom model, as I just showed here. That means instead of 5, you can feed in 50 documents to show the model that, yes, you know what, in documents you might also get certain shadows in that context, pick up these things, right? So all the stuff are, I would say, outlier scenarios which you have to use custom model for that. Yeah, perfect. I presume this is clear. And again, going back to, this was meant to be tutorial, so I would highly recommend that you guys go through this. I put in the link already. By the way, just so that you know, what I showed was Form Recognize 2.1. Okay. Now, Form Recognize 2.1 basically takes you through four labels, right? Four activity, which is invoice, business card, ID, and receipts, right? But let's look at Form Recognizer 3.0, which basically gives you much more capable. By the way, there's also Form Recognizer Studio preview available, which I will just load it up. And this is something which should be easy enough for you to use, like I showed in a studio on a different browser. These are something we should be able to check. See the pre-built model, invoice and receipts, business cards, identity documents, right? And you can do that. Okay. By the way, the inking capability, which is basically part of the Read API, all the stuff is part of the Form Recognizer V2, which I will basically show here, right? So if you look at this, this is the GA right now. 2.1 is in general availability, which is layout, custom model, invoice model, receipts, and ID and business cards. Now, if you look at form recognition 3.0, this is where the read API, read, for example, if you have handwritten style detected, right, which is what I showed in this example. Handwritten text is common in most of the scenarios, right? If you look at this one, um, uh, right, where was that? Sorry, KYC. If you look at check, here we had a handwritten check here. So that means you wanted to basically extract text not only which is typed, but also which is handwritten. This is where we saw earlier in terms of, this is where the OCR API has been used. Yeah, read API, not OCR API, read OCR API, this one. This API was used there to basically detect handwritten style, handwritten language. Okay. Perfect. Hope we're good with this and we can, it's exactly 30 minutes since I started. So this is capsule number 4, which we kind of wanted to bring it to the fore, which is about vision. By the way, there's a lot more to vision. Tomorrow you'll see a few more examples, but we didn't showcase, I would say, let's say, spatial analysis, right? Spatial analysis, just for your reference. I'm not sure, Shikha, just checking, do we have spatial covering tomorrow? Or I'm just checking. We can bring it up tomorrow, but spatial analysis is something which you should know in terms of when it comes to speech, when it comes to, sorry, vision, Azure spatial um, analysis, right? Which basically helps you use your existing CCTV cameras and do 3 things, right? People counting, right? That means imagine, I said earlier, the power of cognitive APIs can be taken to edge infrastructure. And this is a classic example of that, right? That means in a retail store, if you want to do people counting and using your existing camera, that means the model is deployed on a specific compute in the rack at the back of your retail store, right? People counting, entrance counting, because you want to capture footfall, right? This kind of entrance counting for, let's say, a checkout counter. You define a polygon there, and when somebody enters the polygon, it's called entrance counting, and somebody exits, you can probably say the count reduces, right? And of course, the third one is social distancing and face mark detection. All the stuff is something which is a central part of how computer vision as a technique is getting utilized to solve some of the most profound problems as you go along. By the way, the power of cognitive is so much, right? We launched a new service called Connected Space, right? Let me just play that for you, just to service which is built on the learnings we have had in spatial analysis, right? It's called Connected Spaces. I'm just showing it right away. The reason why this is so important, because in retail store, let's look at this retail store. So same API that I showed right now, right? These are called skills. That means you're talking about skills like people counting, skills like, by the way, the stuff you see here. Let's play this, yeah. We are incredibly adaptable to the physical world. Right. So basically, uh, sorry about this. This is not the video, but yeah, let me just zoom this in a bit. Okay. Um, the skills I mentioned right now, the skills, when I say skill, uh, measuring, calculating people entering a retail store. That means that is called basically people counting with the polygon that you define. That's called one skill. It can end cap. So what you see here is termed as, it is called end cap, right? That means in a specific retail store, when people are basically going across an aisle, the front of the aisle is called the end cap, right? You want to measure what are the people activity in the end cap, right? So all the stuff is something which we announced recently called Connected Spaces. You should check it out. And this is purely built on, again, if you see here, the true power of computer vision, and these are pre-built AI models built on spatial analysis cognitive APIs. And the best part is you get out of the box insights. As you see here, you get insights saying, hey, in the queue management, I saw a 28% increase in queue traffic between so and so time. This is insights coming. See, end of the day, all these models using is only as good as what data you get from that, and how good you put that, how you put that data into good use, right? So this is a classic example of, and I thought I'll just make a mention of this before I move on to the next capability. Okay. Hope we're good with this and shifting gears. I'm going to just close these things, which may not be relevant for us now. And must be a close search. Okay. Let's get back to my slide deck. Let me show you one example as before we jump into the next one. I'm going to just close. Yeah. So let's do this. So let's shifting gears to again. This is the second topic is semantic search. Yeah, what is semantic search? Semantic search basically is again it sits on cognitive search, but it understands the context. Yeah, there is context to your search. It is a lot more. It's as good as you building a search engine for your company. So imagine you want to basically make a search available for your organization, and it is as good as any Q&A you do in internet, which is contextual and good. If you search Google or Bing, the results are very contextual, right? In terms of you might say, hey, I'm looking at Bangalore plus restaurants or Bangalore plus, let's say, a cafe. So it will give you cafes in Bangalore, understood, right? Likewise. So let me just show you what is the power of search today. So we saw document extraction, but looking at document search, I'm going to start with the demo once again. So if you look at this, just so that you know, JFK files, right? John F. Kennedy files, which was classified for a long time, was declassified about 7-8 years back, right? Government did that. Now that was a good they made it public, by the way, and that's a good corpus of data. If you really want to, if you really want to search through documents, because there is variety in the document there. So let me just search this person's name who was responsible for the mishap that happened. I'm saying Oswald, and I'm clicking search. Now see what happens, right? So basically, you're getting response from the cognitive, which is cognitive search, with highlight of the content I've searched, right? Oswald is there in this document, which probably is very hazy, old typewriter, old printer, which is giving you some hazy. Second one is handwritten text, which is where we said earlier, right? You can use read API, right? And of course, there's a picture of this person, hence, that comes up, right? So just so that you know, here multiple cognitive APIs have been put to good use to give you this information, right? So this is the true power of cognitive search. And what matters to us most is semantic search. When I say semantic search, by the way, you're asking this, Oswald, but what if you ask a question saying, what is the capital city of, let's say, Karnataka, right? So it should not give you searches of Karnataka, but it should understand that you're asking for a capital name, city name, and it should give you a response as Bangalore and more information about Bangalore, right? And that's semantic search example. If you just search, by the way, the beauty of the search I just showed is it is going to give you access to content which is probably hidden somewhere, and you need to search that. And that's a true power of cognitive search. That's not it, by the way. There's also we also talk about establishing a relationship, which is graph, right? All of us understand graph, right? So if you look at this visual right now, basically, how is Oswald related to other personas, other attributes, right? Other, you can call them as named entities. How will it actually, how is it related to that, right? So you pretty much have the authority to tell the machine saying, hey, I want to be able to relate to people, places, city, region, blah, 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 location, whatnot. And that's how the graph gets built, right? Just so that you know, let me be very clear, right? Just so that you know, if you have data with you, to build a website like this, which will give search, this is a demo site, by the way, this is not a production site. It takes 3 or 4 clicks, period, right? You'll be surprised. I'll show that in a little while, right? So before that, let me just take you through how do we get here, right? We're talking about search, but let's understand how it all works behind the scenes. Okay, now, not this, not this one, right? Now look, so if you look at, you basically will have significant number of unstructured data or structured data or data which coming from IoT, data coming from on-premise, public cloud and whatnot, right? So the first activity you do is data ingestion, right? Once you ingest data, you will have to build search indexes. Yeah, search indexes is what you build, and eventually after you build search indexes,
techniques to understand latent structure in all data.
Okay, so once you basically build search index, as you see, this is a good visual as you see right now, right? To basically perform a semantic search, we're using vision, language, speech, and a lot more APIs. The reason I'm saying speech is because you might have uh, data or something you're searching within video and audio also, right? So hence, when it comes to extracting information, you will bring in multiple cognitive APIs and eventually enable search. Yeah. So we'll see that. And again, just for demo purpose, I'm going to just tell you in terms of which one. Um, Cognitive search demo. Yeah, search demo. So by the way, I've just built this. Okay, just I'll show you how easy this is to build. We'll probably do a good one. This is about cognitive search. I mean, this is semantic search, by the way, because I'm while it says cognitive search, the semantic search is something which is the umbrella on top of it. But this is a sample hotel data that I have pulled in. Okay, I'll tell you how to build that also in a little while. But let's talk about hotels here. Now, by the way, I might just say house. Look, so the results you're getting here, I'm just saying house. It's asking me whether you're looking for a 4 bed, 3 bed, semi-detached, attached, whatever, right? So or a guest house. Now, this is the semantic relevance of what you're searching, right? I mean, that means it is helping upfront in terms. By the way, I've given for the semantic recommendation that it has to be listing ID, location, which is and beds and guest and type of house, which is descriptions, right? That's what I've given as an ask of this cognitive semantic search to tell me, hey, this is basically called predictive query, right? So you predict him, what's the query? Accordingly, you can pull in these things. Then I might say, you know what, I'm looking at 1 bed guest houses. Then it may tell me, hey, there are 5 in this area. See, look how cool this was for me to get to what I want to search for. And this is the best part of semantic search, right? You're not just searching. Imagine if you search for a guest house, it gives you some 500 responses back. It's meaningless for us to show 500 records with 20 page pagination with each showing 50 records, right? Doesn't make any sense at all. This is where semantic search comes in handy, right? Now, by the way, not this. I'm going to tell you which tutorial. I'm going to post that once again here, just so that all of you follow this really well. Yes, this is the one. Okay, semantic search in cognitive search. So I'm going to just post this link in the chat window, and you guys can search for this and practice. Very simple, actually. Okay. Yeah. By the way, all of you following what I'm saying, just a quick yes will do because I've been speaking. I'm sure Shikha is keeping an eye on the chat window, but just a quick check. A quick yes would do if you're following what I'm saying. Interesting. Somebody has put hands up. I would say just put a yes because it's easy for us to know that there is an action happening. Um, if less S's are coming, that means a lot of you um, not getting, which I hope not. So we need more S's coming in. See, that's what I'm trying to force you guys to say yes. But yeah, you know what? Feedback is welcome, right? So if you will spend, as I said, it's 12:40 night now. I'll take 10 more minutes and then I'll hand it off to Shikha. That will be 1 hour of my time. And then Shikha will spend 35 minutes and then we'll do a good Q&A. We'll good because this is where it has to be more real for you, all of you, because we've spoken about 7 or 8 techniques which are a topic in itself, right? So hence we will spend 30 minutes just to answer all of the questions you may have and we'll take it from there. Okay, thanks so much, people, for your quick acknowledgement, and we'll take it from there. So now, I said semantic search. I'll just show you how easy it is to build a semantic search. Okay, I did this yesterday evening, and let's see how to do that once again. I'm going to just close stuff which are not required. Okay. So basically, there is a search service. Now, if you when you do a semantic search, I'm just already done it here. I'm just going to open that. Yeah. So right, semantic search preview on the left-hand side. Let's look at this. When you want to create a semantic search, basically go to the dashboard. create new service. Sorry, here, home. Yeah, create a resource, and you basically say semantic search. Yeah. Yeah, basically cognitive search is what you create a resource, and that will help you create semantics. So right, so you just go create, and you can do all these things, right? You can enter subscription, all the stuff, and I've done it already, so I would not do it once again. But when you get into the semantic search, I've named the semantic search by the search service, and this is where you basically, no, let me just do one more thing. Sorry, just give me a second. Yeah, so you see this at the top. I'll just zoom in for you. Once you get a search service, right? The search service, it's not a cognitive search, but it's a search service. My bad. I'm just going to do once again, just so that we're clear. It's basically a search service. Oops, what happened here? It is okay. It's tagged as cognitive services, the cognitive search. My bad once again. Right. Let's go here. So typically, when you do this, first thing you do is import data. Right. Now you can look at I've basically imported real estate sample, right, as an example. But otherwise, you can bring data from anywhere. As I showed in the visual earlier, the data can come into your search engine from any of these resources. So let me pull up once again a new one. I'm going to pull up from, while I did real estate, let me just pull hotels sample. Okay. Now, when I select a data sample, it tells me add cognitive skills, right? I'm going to just do that. Let's see what options I get, because this is where I need to tell, looking at my data, I know my data really well, right? So I'm going to attach cognitive services here, which is, there's already, by the way, I've chosen a limited enrichment here. That's why you don't see many of the stuff, right? Because I've chosen a free tier, not to waste money. But let's look at add enrichments, right? This is where it is interesting. I want to basically, when I say enrichments, I want to be able to recognize in the data, extract people names, organization names, location names, key phrases, detect language, and if there's a need to translate text. From translate text, I might know that I might have it in Hindi. In the language, I might say, what, from English to, I can say translate text, right? Target language, right? That's what it is. So I'm just doing all this. Now, save enrichment to knowledge repository. I'm not too concerned about this, right? So that's okay. I might just do customer target index. So this is where indexing, this is the important step, because eventually you want to index it. This is because you mentioned earlier in the stuff saying, these are the categories I want to basically add skills. And now you're saying, I basically want to ensure that I index on this data. By the way, this is hotels. This is basically the hotels one, right? So that's where it picks up the name, description, all the stuff is already there, right? I'll not do anything. I'll just create an indexer. Okay. So yeah, hotel sample indexer, that's fine, and submit. By the way, I've chosen a free tier, and hence I don't have this schedule option. Otherwise, you can, as you get new data, by the way, right, you need to index it. So you can run index hourly, daily, or you can define a time period that you want to run it. Yeah. So right now, what has happened is it is successfully configured, right? So it is basically successfully configured, not configured, successfully done the indexing, right? And let's do a search explorer. Let's see what happens. Now, this is, by the way, it's all there. I've imported data, I've done this, and let's do search explorer. And in search explorer, it's basically, it gives an option for us to create, let's say, hotel, give a search. Search, what happens? Yeah, I get something here, but I also get an option to um, create basically, a simple page, right, which can help me search that, like I showed earlier. I'm just looking at that option. Um, yeah, one-side index, semantic search. Yeah, so basically the page you saw earlier, right, which is right here. Let me just go back to the page. This one here, this one here. Sorry, not this. You know what? Let me just stop sharing. I think I lost the link to that page. Just give me a second. Yeah. Just give me a second, guys. There is a way for us to just extract, just post it for a basic testing, which is what I'm looking at here, and it should be there uh, in the page. I just posted for you guys to refer it. Yeah, just give me a second. I should get it in a second. Enable semantic select plan. I've done it. Disable semantic. Um, okay. IG portal, query options, using REST API, semantic. Just give me a second. My bad. I just lost in the portal where I could just get this stuff. I know I'll get back to that. Don't worry about it. I will get back when it comes to Q&A. I'll just absolutely get that um, search back again. So basically, the UI you're going to get is exactly what I showed earlier, which is like this. Okay, for the data that I basically we trained right now, which is restaurants. Earlier it was hotels. We didn't restaurants. Now the restaurant search. And by the way, it's going to give me. If you look at this, it's a local file, right? It gave me HTML file. Of course, there is a link to the REST API call you're going to make is embedded in my search result search here, and this HTML is given to me, and I can this is not a production quality, by the way, right? It's only for searching purpose. So now, just like I said earlier, I can search anything here, and this is how the restaurant search will also work. I'm going to come back and show you once Shikha finishes in terms of where to get that demo.html file or easy search.html file. It's a very simple one, no brainer. If any of you have done that, just post it there. Otherwise, I'll get that across. It's a very simple one. I don't know why I missed that. But otherwise, to build a cognitive search, right? In terms of, let me just run this video once again so that all of us are clear. It's a no-brainer. There's something which basically you should be able to do it with absolutely no coding, honestly, right? Because all you've done is you configured multiple endpoints. By the way, we chose an Azure SQL and a Cosmos. That's where the data came in from, right? But otherwise, you can absolutely add import data, define the skills, define cognitive skills, define semantic skills, and generate index, and that's about it, right? You get a REST API endpoint, and you should be able to embed the search. See, this is the beauty. You can embed the search in any of your application, right? That means for an organization, you want to bring in semantic search, which is contextual search, and you know your data really well. And you can absolutely embed this search bar like a Google or Bing search for your organization in no time, right? And the best part, I think one thing you have to understand, the data is always incremental. Every single day you get more data. Hence, you'll have to index it. That means you can run an indexer on a scheduled time every single day or every single hour, depending on how what volume data you get. You want the results to not to be stale. You want results to be latest and greatest. So you can run semantic search twice a day, thrice a day, right? And make sure the search is very, very relevant. As I said, the search does not only give you textual response, it can give you a response from images, videos, audios, text, and whatnot across the board, and to be relevant response coming back to you, right? The reason I say relevant response is your question is not about a keyword saying search me hotels. You're saying which hotels are good in Bangalore. So you understand that good Bangalore and hotels. So it'll should probably show all the hotels which have good rating in Bangalore, and that should be a response back, right? And just so that you know, when it comes to conversational AI, a chatbot, this is where the API is available for you. You can absolutely invoke them through a chatbot, and that way you don't have to have UI like this, and you can ask questions, and response can come back. In terms of top three can be shown as a response in the chatbot saying, hey, if I found top results on your search, that's very, very relevant in that context. Yeah. So I think I'm just on the hour, which is 52, which is I started 55, so 1 hour of my time. So this is where I'll take a pause, and I'll switch back to the chat window. I'm going to just work on getting that demo.html file. I'll show once Shikha finishes. Otherwise, any questions any of you have, post them in the chat window, and I'll be more than happy to answer them. Yeah. So we saw two capabilities right now in the last 1 hour. One, of course, is semantics that you just saw. Other one is document processing. These are two key capabilities. Any industry you take, these are two use case that is dominantly available. Yeah. With that, Shikha, back to you.
Thank you. Thank you. All right. So now in the next an hour or so, 40 minutes or so, I will touch upon two topics. So the first one is ML ops and the other one is responsible AI. And both of them are super important. Actually, they play a foundational role in us being able to productionize our models, right? So I mean, we essentially when we saw your machine learning platform, we could see that it serves as a central place from wherein we can have access to entire sort assets. So be it our data sets, be it our models, be it our endpoints, be it our compute, we will have complete visibility from a central platform about all those assets. And this essentially streamlines collaboration, it democratizes access, right? And then the next aspect of ML ops is really operationalizing the entire life cycle. So early on, there was a question: can we continue to use the tools that we use currently? So absolutely. So with ML ops, what you can do is you work with a small size of data on your own machine in the environment of your choice. And when you are comfortable with the code, you can essentially automate the entire process of training the model, um, uh, uh, first of all, actually creating the environment in which the model will be trained, right? Because when we train our models, there could be so many libraries, there could be different even operating systems. So, first of all, to be able to reproduce that training environment, then train the model, then deploy the model, and of course, then the next step is to be able to actually have insights about how our model is performing. And oftentimes we want to do A/B testing. That is pretty much the norm as we productionize. So we might be having a model version, and then we'll have another version, and then we will want to route different portions of traffic to different versions of our model. So all of these activities can be actually automated and facilitated with the AML platform, and I'm going to showcase how essentially we can do that. So, if we talk about ML life cycle, it involves data preparation, building and training the model, deploying the model, and managing and monitoring the model. Now, as we talk about data preparation, there are certain key steps there. So, transforming the data, performing data quality check, feature engineering. So, these are the three, inherent steps in data preparation side. Now, with Azure, what we can do is we can work with, familiar engines. So if there was a need wherein we wanted to work with Spark, we can make use of Spark there. If we wanted to integrate with Synapse, which is our data analytics platform, we can do that. And we can Azure, as I demoed earlier in the session, we can directly access data from where it resides. So it could be in Azure Data Lake 2, it could be in SQL, it could be in Postgre, etc. And we can, directly work with that. The other aspect is when we deal with unstructured data, so like imaging data, we need to label it. And then we have tools that enable us to easily label the data. And another thing that we as data scientists always lean towards is working with the raw data because data is really the key, right? That is what is enabling us to create the solutions. So let us say if we did have a data source, to be able to figure out the data lineage is super important. And with Azure, we get that ability as well. And then of course efficient data exploration. So I showed you how we can utilize the inbuilt profiling capabilities for data exploration. Now, of course, we can make use of so many other libraries for our exploring the data. Now, talking about the next steps, building and training the model, right? For that, the first thing is, of course, we need to have a reproducible environment, and Azure lets us do that. And then, of course, we build the model. When we train the model, we will be working with the IDE, and then we will then evaluate, basically multiple experiments, and then we will want to track how the model, as we iterate, how the model performance is evolving. So with Azure, essentially, we can build the model by using the tool of our choice. We can, train locally and submit on a smaller side of data, and then submit the training run to cloud easily. We can basically perform distributed training as well using NVIDIA processors. And then in terms of model management, we can use, we can see that the entire set of outputs are stored in a central repository, and rich set of logging and insights are available for us to consume. And then model explainability and debugging the models. This is something that we will touch upon in greater detail as we talk about responsible AI. So these are some of the tenets because of which, we find it very easy to really operationalize our models. And talking about deployment, basically, as we deploy, training the model is only the first part. We need to deploy, and then we need to check how the model is performing. And so, we need to have a mechanism by which we can capture the responses of the models, validate it against the existing behavior, and make sure that the model endpoint is scalable depending on the needs. So we might have a need for batch inferencing or real-time inferencing, and we should be able to fulfill all those needs, right? And with Azure, essentially, we can deploy the models easily in Docker environment, in container, or in Kubernetes. And Kubernetes definitely gives us scalable inferencing capability. We can deploy models and capture all the insights. So we have that option as we deploy, whether we want to capture all those insights and analyze basis that insights, including the output that we get. And that is also kind of a fundamental need in regards to managing and monitoring the model. So with Azure, we have multiple options to monitor our model performance. So we can essentially use entire monitoring capabilities in Azure machining, monitor application insights. The entire set of capabilities are available there. Also, using Azure Event Grids, we can get different types of statistics. So bottom line is, with all this, we get an environment wherein we are able to collaborate seamlessly between teams. We are able to automate different workflows, model versioning, compute resources, and management, and the entire management of models is actually handled by MLOps. And it is because of this reason that customers like PepsiCo, they essentially utilized Azure machine learning platform, because with this they were able to tremendously improve the time in which they could really deploy the solution. So they were able to reduce the time from months to days for new solutions. Similarly, AGL saw a massive improvement with MLOps. And with that, let me share my desktop for a few demos there. So typically, what will happen is we will be working in the environment of our choice. So, for example, here I'm working in Visual Studio Code, and this code will be actually residing in our what do you say, in my GitHub repository. So for example, I might be having this GitHub repository wherein I have the entire set of code there. Right. So, if I were to kind of walk you through some of this code, that how it would typically look like. So there would be there would be some code wherein we will be essentially loading our data set, splitting into train and test, and then training the model. Figuring out the accuracy on the test data set, figuring out different other parameters, and so that will be the training side of things. And then we will have some code to test our model. So there will be a test script there, wherein we will be essentially testing the model. Here we are having a hard coded data, but there could be a scenario wherein we could be actually taking the data in from the web service, and then it could be basically making the predictions on top of that data. Right. So this is the test. And then let's see what is there in the deploy. So here I have the scoring thing. So I'm testing on a hard coded data, and here I'm basically getting the data that I'm receiving from the user input, and then I'm making the prediction on this particular data. Right. So these are some codes that I'll have. Now what I can do with MLOps, and which is facilitated by this beautiful option in GitHub, is that I can define a workflow. So like for example, this is a sample workflow. In this, what I'm saying is, whenever I push the code onto master branch, I can actually, what I want to do is, I want to train my model. And for that, the various steps are, I check out my repository. Okay. And and then, so here, this is basically the action that I want to check out my repository. And then the next thing that I want to do is, I want to essentially connect to my machine learning workspace. Then what I want to do is submit a tray. Then I want to connect to my compute, and then I want to submit my training run. Then I want to register my model, and finally I want to deploy my model. And also, what I have done is, I have defined these parameters. So for my workspace, I have defined that the name of my workspace is Smolin. And I've said if the workspace does not exist, then I would want to create it. Similarly, for my compute, I have defined the name of my compute as a GitHub cluster. And similarly, for registering the model, I'm saying that I want to name my model file as model.pickle. Now, what will happen? When I make the change, and typically how the change will happen is by someone actually editing the model on his IDE, and then he will as he will push the change onto master branch. That's when this workflow would get triggered. For demo purposes, I'm just making the change right here in this file, and now this workflow that we just saw will get activated. So you'll see here, this particular workflow has got queued, and very shortly it will become in progress. So now it is in progress. And now what will happen? Here, as of now, if I see these computes, none of these computes are actually activated, whereas I am actually going to use GitHub cluster. So we will come back to this and see if we see that there are any active runs to it. Okay, and after the compute, it connects to compute. It will submit a new experiment. So as of now, what we see is that there are like these many experiments for this MLOps basic training run. And so the last one was on Jan 12th, and very shortly we should see another entry here. And as you can see, for each entry, we are able to see when it was submitted, how much time it took, what was the various metrics. If we drill down further, if we open any particular entry, we can see what was the script name that was used, that was basically executed as part of this training run. Were there any data sets there? What was the environment that was used for this training run? Right, and we can essentially see the matrix, the entire set of metrics. So we can see what was the accuracy, confusion matrix, F1 score, kernel type, penalty, etc. Even the graphs we can see. Now imagine if as I train my models, if I wanted to have a mechanism to log all this manually, imagine the effort that I will end up incurring, right? So with this Azure machine learning MLOps solution, the entire set of statistics are logged, and so they are available for everyone to see, and even for the data scientist himself. So it makes it very easy for him to check how actually the model performance is evolving. Right, of course, in the outputs and logs, we can see entire set of activities here. Now, once the model is trained, of course, we will be able to kind of, see other things and deploy it, right? We can see what are the artifacts for that run. So like, because we gave model as the name of the artifact, we see that there is a model.pkl file there, and we can download it. So this pickle file, we can download it and then use this for inferencing on our local environment, right? And after deployment, we will see an endpoint, and we can then work with the endpoint. So now, of course, as we deploy, there are several aspects, several things we can specify. So if we are deploying multiple version, we can even do A/B testing. So if there was another version of the deployment, we can specify lesser traffic on this particular version. That way, we can gradually ramp up the traffic onto this newer version of the model. So now let us see what if my compute is showing any active run. So as of now, let us see what is happening to the model here. If I basically see my GitHub cluster compute so far, I see that it is not happening, and I see that here there has been an error. So let's just we can actually see what's the error happening here. So if we see here, there we get detailed logs about this. So it says get token request HTTP 401 server invalid client. The provided client secret keys for app are expired. Okay, so now, so as you can see, it is basically helping me understand why this run did not go through. And for that, in my basically security settings, I have to specify, the settings here in as to what the keys are. And once I update those keys, that's when the run will successfully execute. So if I show you the previous runs that I executed here in my logs, right, I will be able to see exactly how the workflow progressed. So I was able to essentially connect to my workspace, connect to my compute, connect to my ML run, register the model, and finally deploy it. And this is what basically executed in Gen 12. And this is what we can see here. This is basically that run. Right. So this is any questions in regards to this?
None, Shikha. Go ahead. Yeah.
Cool, cool. So with that, let me switch to the final topic for the day, which is responsible AI. So for that, let me open my presentation. All right. So if I look at responsible AI, right, there are six pillars of responsible AI. Which is fairness, reliability and safety, privacy and security, inclusiveness, transparency, and accountability. And essentially, the thematic is that we want to ensure that as we train these models, these are inclusive. So, which means throughout the process, we will want to make sure that different sections of the society are included. So, this is something that we stringently follow. So, any of the cognitive APIs that I talked about, there will be, there will be a focused effort to make sure that we take inputs from different sections of the society so that our models are not biased and models are not conforming to societal biases. Then we take efforts to ensure that the data is secure, the security needs are taken care of, all the governance aspects are met. Then the models that we train, they need to be explainable. We need to be able to understand how our models are making those predictions. And then the models need to be fair. And we need to be really aware, how the models are basically performing on different types of data. Um, and we'll talk at greater depth around this. So, moving on further, right, where as we essentially train the models, there are several basically aspects that we deal with. So, like what features we need to work with? Is my model really good, right? How can I improve my model? Right. And finally, there have been so many scenarios when we talk to customers wherein they say, we have built the models, but we are not feeling comfortable operationalizing them, taking them to production. So, and the primary concern is they're not very sure, A, how the model is making the prediction, and B, whether the model is going to be fair. So, with that, they're essentially not able to trust the models. Like just to give you a simple example, right? I might be getting 73.8% accuracy for my model. Now, how do I know if the model is having this accuracy for entire data point? It may be good if I look at the overall percentage, but what if the model is having very low performance for a certain cohort of data? Right, and I am not even aware of it, and I'm using the model assuming that it is giving me 73.8% accuracy for the entire set of data. That is going to be disastrous. So what we have is a responsible AI dashboard, and I will attempt to show you a demo of this, which will essentially help us perform this extensive error analysis. Right, and error analysis is also kind deeply associated with fairness. So, like if I understand that this accuracy of let's say 95%, is not same across. Let's say for a certain gender, the accuracy is only 70%, right? And if I am aware of this, then I can take steps so that I deal with this model in a fair manner. So either I can take steps to mitigate this, which means both the genders will have same accuracy. I retrain my model and get rid of that unfairness. Or if I am aware and I'm making a prediction for, let's say, a gender for which I know now that the model is not giving me correct results, then I can involve human intervention. Right. So basically, with this, I can actually make sure and I can be confident that I am dealing with the model in a fair manner. And so we have tools in place that gives us insight in this regards, and responsible AI dashboard is one such tool. And it is because of these capabilities in Azure machine learning platform that Philips, when they utilized AML for their ICU models, so they wanted to ensure that the models perform similarly on patients with different ethnicity, and they were able to accomplish this objective. Similarly, if we talk about EY wanted to again make sure that the model disparity between men and women, as they create a solution for loan disbursement, is minimal. And using the fairness toolkit that we have, they were able to accomplish this. Now, the other aspect is once we are able to do this error analysis, then to be able to essentially understand how the model is giving results. So the model should not be a black box for me. So again, interpret ML is one such functionality, and I'll take you through demos around that, how it helps us understand how the model is performing. And finally, if we talk about the scenarios wherein let's say there was a person and he was, let's say our model said that the credit rating is not so good and hence the loan will be denied. So the person might say that what is it that I need to do to be able to get this loan. Now I will show you how with counterfactual analysis we can see that with minimum disruption, what is it that needs to change in the data set so that the prediction changes. And those insights can be very, very valuable when we really productionize the model. So it will not be as as black box or as non-human like behavior wherein we just come up that because the model says you are going to be denied the loan, we can actually help the person understand what steps he needs to take so that in future he can be basically a valid candidate for a loan disbursement. So with that, let me share my screen for sharing with you the responsible AI dashboard. So here what the way basically it works is, let us say we have a certain data and we want to train a model. So basically this is our usual sklearn libraries that we are going to be using for training the model. And say in this case we are using light gbm classifier. So we have some data which looks something like this. So we have person's age, work class, education, education number, marital status, so on and so forth. And then what we are essentially trying to predict is whether the person's income is going to be less than 50,000 or more than 50,000. So for this, we train this particular model. And then as you see at the top of this notebook, there is this responsible AI dashboard library. And how you get this is you can just do pip install responsible AI widgets. That's pretty much it. Once you do that, you can import this and you can import RAI insights. Now, after training the model, what you do is you essentially instantiate your RAI insights. You tell and there are parameters, simple enough. So you tell the model what is the train data sample, what is the test data sample, target feature, and what type of model it is, and what are the categorical features. And after that, you essentially tell to this in that what all you want to be added. So, for example, in this case, I want interpretability, error analysis, and counterfactuals all to be added. And then we ask this RAI to compute. And once it is done finishing, it gives us this particular URL on which we will be able to see this dashboard. So let us see what we see over here. So here, on this dashboard, what we see is this entire error analysis. Now, what exactly are we getting to see here is um, there is a total of 500 records, out of which 73 of these records are having error. And now what you see here is like this particular section, this particular is having 65 out of 311 records, right? Now what is this? This is essentially here, essentially the age is greater than 33.5, right? So what we see, the error coverage here is basically 89.04%. And if we see here, like the error coverage is 10.96%. So what we can, so basically it gives this beautiful, this tree, error analysis tree, wherein these red things, they are essentially telling us, uh, you know, um, basically that the error percentage here, error coverage here is like 42.47%. Here, the error coverage is 46.58%, and the error rate is 15.96. Whereas in this case, the error rate is 31.63. Right. So what that means is, uh, in this particular cohort, there is an error of 31.63%. Whereas if we look at the overall level, the error percentage is 14.6%. Similarly, if we see here, the error percentage is 37.5%, right? And here we are having 36.99% error. So if you see, this particular cohort is having the highest error rate. So now we can save these things as our own cohorts. So like if we see here, here the age is greater than 33.5, less than 50.5, and the hours per week that the person works is more than 44.5. So we can save this as a cohort. Now, if we look at this, in this case, the age is greater than 33.5 and hours per week is 44.5, right? So if you look at the difference in error rate here, there 31.63 is the error, here the error is 37.5. And similarly, we can save this as an error cohort wherein the error rate is 20.9. Now, once we save this, and we can just, save this as a cohort here and give it a name. So this is like, age more greater than um, 33. And we can save it, right? We can save this as a cohort. So now this is saved as a cohort. Now what we can do going below is like we can essentially see how these cohorts are basically, working. So we can see that in these cohorts, right, the probability in this particular cohort, the probability that the salary will be predicted as less than 50%, in this cohort it is higher, whereas in this it is lower. So we can see that there is a difference. And then we can perform data exploration here to understand more. So if we look at this entire data, what we see is that the median age here is 39.5. Here, median age is 36, median age is 36, median age is 34, so median is 38. So median age of all the people is to the range of 36. Now let us see these other cohorts. Of course, this is greater than 33, so this cohort is definitely going to have higher range, right? Now let's say we create a new cohort here, and and so we can see here, right? We can essentially see here that when we basically access these cohorts, we can perform this error analysis, and we can then see that these different cohorts, what is the reason why it is not performing, model is not performing correctly. So we can see that the number of points uh, in these two cohorts are actually quite different. So if we see in this cohort which is not performing correctly, we see that the number of people suddenly with large number of salary, higher salary, is much more than in the overall data set. In the overall data set, the number of people with high salary is much less. Whereas in this particular cohort, the number of people with high salary is more, and so the error is increasing tremendously. And knowing this, now we can take the mitigating action, which means in the overall data set, we want to have the more people with higher salary, so that the model can learn better and train better. Talking about the model interpretability, so feature importance. Here we can see that the model is actually giving maximum importance to marital status, followed by education, followed by capital gain, and followed by age. So basically now we can understand how the model is making predictions, and it is no longer a black box. Similarly, here we can perform individual analysis, and by making this analysis, we can then see, we can share insights with the person that today, if his salary is less than 50K, what is it that needs to change so that the salary becomes greater than 50K. So basically this serves as a very powerful tool, using which we can perform error analysis, understand about the model, and perform counterfeit analysis. And this particular project, RAI dashboard, is an open source project, so anyone can go there and have a look at what's happening, make contributions to it, and continuous improvements are being made here. And as we saw in earlier sessions, this entire model fairness, this model explainability, this is integral part of automated ML. So as we train the models in our model explanations, we get this entire insights about how the model is basically making the predictions, using which we can see whether it aligns to our logical thinking or not. And the last thematic that I want to touch with you is of differential privacy. So basically, what happens is, if we have certain data, and let's say we publish this data on to any site. Now, what can happen is, even though we might be publishing aggregate data, if we if somebody, let's say, accesses this data many times and has information about individual data points, using stat solver, he can actually get insights about the individual components of data, which will be a serious violation of the data privacy norms. So again, Microsoft has developed a library called Smart Noise, and with Smart Noise, what is done is a certain noise is inserted into the data. So the original data and the data with noise, it is good enough for training models and for consumption, but it makes it virtually impossible to figure out the individual data points. So and also eventually there is going to be a mechanism in place wherein as we request for data in AML, there will be quotas. So depending on the quota limit, we will be able to get the data or not, thereby making it ensuring the data privacy concerns. So these are a couple mechanisms by which we really ensure that we essentially take care of all the responsible AI tenets, and are able to make sure that we give a great degree of comfort to organizations as they train models and look forward to productionizing them. So with that, I'll take a pause and see if there are any questions.
Yeah, Shikha, there's one question there. I don't know what was the relevance. I missed that from David. Um, and there's also one question from Ketab, deep learning models in MLOps. So you can just take that. Ketabnath Srinivas and David.
So, what is the equivalent tool for experiment tracking in Azure, or do we have to use ML flow for that? No, so in Azure, the entire experiment tracking is happening in the platform. I mean, as you could see, the entire, the as we run the experiments, the entire set of tracking is actually taken care of for you. So, yeah. So, David, hopefully that answers your question. You really don't have to use explicit ML flow there. That is the beauty of Azure machine learning platform. It is taken care of for you. Yeah. Yeah.
Yeah, Shika, I have a question regarding that ML ops. So
Yeah. Please.
yeah, so you have shown the ML models, training, deployment, and analysis of errors and all, right? So in same case, like I'm having a doubt about deep learning models. So can we host like that? We can do the same analysis over the data and all.
Great question. So for deep learning models, you can definitely utilize the entire Azure machine learning platform. And in fact, I do have a deep learning model experiment in that. Let me kind of take you to that repository. Let me just do that. Um, so but you cannot perform that kind of error analysis for sure. So
Yeah,
that is not possible. So let me just trace my investor experiment here. Um, yeah. So yeah. So this is a deep learning experiment that I have here. Um, And so for this particular experiment, right, I can only see the statistics in I mean I can track the models, etc. I can deploy them. I can get insights as I basically work with the as I score. So I can definitely get statistics in regards to how I am making the what do you say? How I'm making the inferences. What is the output? If there is a data drift, etc. But I cannot perform error analysis using the responsible AI dashboard for sure.
yeah, because we'll be having many more parameters. And,
No, you are absolutely right.
yeah. Fine, fine. Thank you. So I could see here we have every model is there. I mean, model not machine learning model, but every use cases where we can do with Azure and also. Is it there for free version so that we can experience every modules to check how to get involved in?
Yes, there is definitely a mechanism by which you can get a free Azure subscription. Let me see if I can find out the link.
Okay.
If there are any other questions, I will try to find out the link and maybe share that.
Sorry, say it again. I missed the question. Is it about the free subscription?
Yeah, free subscription.
Yeah.
Yeah. No. So you get a trial account.
Mhm.
So you have to sign up for a trial account. Um, that's the option you have. So I think I pasted the link at the beginning of the session. So you get some credits, and it's a 2 months. Um, I think time you get. So that's what we have as a free subscription.
Okay, because here now we have multiple modules, so I just want to experience each and everything.
No, you will be able to. You'll be
Yeah,
able
yeah,
to
thank
use.
you.
So
That,
as long
that,
as
that-
you spin off a basic compute, you
yeah,
don't really use heavy compute there, so it should be okay.
thank you.
Yeah, just to get a sense of everything. Yeah, yeah.
Would we be also able to use the 8 hours guest mode
Yeah.
version environment multiple times, or is it once per user?
I think I don't think they're capturing any users, so just check it. I've not tried it honestly, but we had
Yeah, because
the
I tried
space.
and it's asking for a sign in
Okay, that means it's a one-time thing. Yeah.
one time.
Because by the way, that's a classic mode. That's we've retired right now. So that's been integrated into ML Studio right now. What I gave you the link was on the standard 8-hour workspace is a is a is a dated studio, but what happened inside is same as what you do in Visual Designer within ML Studio. Yeah, but
Okay.
hence I would say sign up for a trial account, and you won't burn $200 in overnight, so you'll be able to play with it because they're all basic services which depends on data and compute. Don't spin off mini compute. Use shared clusters to train. That should be okay. Yeah.
No, I think as long as we are not using visual services, the compute should be low
Yeah. Absolutely.
consumption.
Absolutely. Yeah. Cool.
And
I think yeah. So feel free to right now. So we're open for questions, right? As you're asking, please come forward, ask questions. I think it will be good if you can switch on the videos. I think it's only 2 videos you've seen from that time. We would love to see who's on the other side. So bring up your videos. It's a great way for us to connect. So please do that. And yeah, thank you. I think Karimilla, thanks for switching on a video. We need more videos, guys. Come on. This is a virtual. It's been the virtual world, and there's no better way to connect than videos.
Sandeep, I have a question. When you are training a
Acho, why don't
model
you?
and deploying a model,
Yeah, yeah. Why don't you switch on a
uh,
video and ask a question?
yeah,
It's okay. Go ahead.
definitely. I am
No,
in
go ahead, go
office,
ahead.
so
No, no,
yeah.
I'm okay. Okay. Just go ahead. I'm just joking. Please go ahead.
So basically, when you deploy model on Azure Machine Learning Studio environment,
Yeah.
how do you track model drift, data drift?
Shika, you want to take that?
Yeah, so there is like couple mechanisms to handle that. So one is like you can track data drift via capturing responses as the model makes inferences, right? So typically, and then you can monitor the trend. So if let us say you see an anomalous trend in the way models inference, let's say a certain class, suddenly we see a greater percentage of that class being predicted, that would be indicator of a data drift. That is one mechanism. The other mechanism is we do have built-in data drift mechanisms, and I'm just going to share a link for that document. Just allow me to share that link while we work towards other questions. I'll just share the link in the chat window.
Perfect. Thanks, guys. Thanks, Aditya, for coming on video. Cool.
If we use Azure environment to train the models, and then once the models are built, I believe you have a scripting service where it will convert the model into one of the scripts either in C++, Python, or JSON, right? not JSON, sorry, Java, I believe. You can
Okay, so
export the model.
two things. Typically, when you look at any model development life cycle, once you build the model, right? Typically, you take in containers, right? There's an option to just a single click, you can push the model into a container, and of course, you can take the container to wherever you want to take. That's one in terms of taking the model wherever you want to take. You're talking about export. Now, export of a model looking at the target platform is a capability which is there in, let's say, custom vision as an example. Of course, here also you can export. Export means you're taking the model out and it came in containers or otherwise also. But in terms of exporting to a specific platform, it can be Android, it can be iOS, it can be Windows or anything else. Custom vision kind of gives you export vision models into multiple platforms because that's where you actually deploy it. Number three, if you look at automated machine learning, which is what Shikha showed us as a demo earlier, once you build the model, it basically gives you Python code, IPYNB files. So you can take that forward and look at what has happened inside and all the stuff. So it's not a black box. The black box is feature engineering and hyperparameter optimization. But once you've done that, if you choose to go with any specific, let's say in a regression, you want to just go with specific model that you always have believed in terms of accuracy. So you can get to the Python code and take it forward from there. So it's Python basically. Yeah.
Yeah, Sandeep. So one more thing on the ML ops, right? So is there any delivered use case in terms of ML ops? Um, what I mean is like, is there any use case that is using ML ops?
Oh,
You mean, is
absolutely.
there
Yeah.
any customer using MLOps?
Yeah, correct.
Yeah, definitely. So I showed you a couple global customer success stories, including EY and including several other big names. In fact, MLOps is something that is seeing that sees catches most customers' attention because of its ability to really operationalize, take care of entire governance aspects. So there are many customers using just this aspect of the AML platform because you can even
Okay.
deploy models that you've trained at your end, right?
Yeah, but there will be a constant monitoring, right? So as a data scientist or an architect, we will be having a continuous monitoring of the ML ops, right? It's
What
like
you
the system
like?
does have it. I mean to say, there will be a human intervention in that, or it's completely the system does everything. So it sees the performance monitor
Yeah,
and
no,
then
yeah. So great question, Garimela. So see, the thing is, when we talk about ML ops, it is encompassing a whole set of activities, right?
okay,
So starting with uh, automating training the model,
yeah,
automating bringing up the compute, right? Now, automating deployment, automating monitoring the model performance post deployment, right? And as you can imagine, there will not be a single paradigm that will apply to all the use cases, right? So
okay,
there will be certain things that you will want to automate, certain things that you want to that you will want to semi automate, certain things you will want to keep manual, right? So you have that ability to take and automate wherever you want. You have that capability, and then you can basically choose to implement what essentially aligns to your use case.
okay. Yeah, I I just bring out this point because if system does everything, our jobs will be on stake.
No, that will never be the case. Your job will only get more interesting as system automates because you will be able to do what the computer cannot do. Right now, you are forced to do everything. Imagine at one point there were huge amount of people doing just data entry job. Now, how interesting can that be, right? Looking at your PAN card, looking at your passport, and feeding in the data entry, and etc. Today, you can engage in much more interesting work. So that is what is going to happen even for the data scientist, right? Why should you write similar amount of code and then write code to capture and then have a mechanism by which when your manager asks, okay, how is your training going on, and you compile all sorts of statistics. Right now, you can just give access to the platform, and the manager himself can see how the model performance is evolving, right? And you can focus and maybe focus on your health and maybe focus on your certain other activities rather than kind of getting bogged down in these mundane tasks. Your job is never going to be at stake.
Stake. Exactly. So one more point over here is like ML ops works for different modules. Like, I mean, it will be different for NLP, different for computer vision, and different for predictive analytics. It will be different for three aspects, or it will be similar kind of approach itself.
No. So see, the thing is, from the perspective of how Azure AI platform looks like, right? So you have AI available in the form of cognitive APIs, right?
Correct.
Wherein you just have these APIs available. You have the option to customize these. So their MLOps will take an entirely different, scene. Then you have applied AI services like form recognizer, like what Sandeep showed you. Search, Azure Cognitive Search, wherein you deal with MLOps in a very different scenario. All you are possibly concerned is how accurate the prediction is. And then you have this custom machine learning model. And when we talk about even custom machine learning, as you rightly pointed out, there are scenarios wherein you might be dealing with text data. There might be scenarios wherein you might be dealing with
Image.
images, and then structured data. Now, as of now, you can work with text data using AutoML. You will very shortly be able to work with image data using AutoML, and then of course structured data AutoML is already facilitated. So depending on the type of model, depending on the type of use case, the some of the aspects will change, but the overall aspects of being able to track the experiments, track the statistics, track the output, right, get insights about how the model performance is behaving, those managing those remain the same. So from a central platform, you can see what all models you have, what all endpoints you have, what data sets are there, how the data sets are evolving, what is the various matrices in different versions. So all that mechanisms would stay the same, but finer nuances will definitely change.
Okay. Thanks, Shikha. Thanks, Sandeep. Yeah.
Thank you so much.
So there is one question. Can we have ML model inference running on Android or iOS device? Will they give you same accuracy as that of a model inference running on the server? See, two things. Let's take an example of the custom vision I mentioned. When you want to export, you can export models to be deployed on this iOS, Android, and there is a compression technique there. It's called compressed model. And of course, compression, when you compress, basically you're using, let's say, pruning or quantization, some of those techniques, and that means your accuracy slightly comes down, right? But you're talking about ability for us to take it to these platforms in a very compressed fashion because you don't have the compute power, compute horsepower to run those models, right? Hence the accuracy dips. But if it serves the purpose in terms of the basic things, why not? In fact, in the current times, if you look at speech models, you'll have to deploy speech models in areas where there's no connectivity and there's very less compute. So in fact, there's engineering innovation happening to see how we can bring in with embedded speech models. That's what Microsoft is innovating in a significant way. Yeah, so it's all, these are the techniques that are coming to ensure we have a compressed in terms of size and all the stuff. But of course, accuracy takes it at times. That's what it is. Yeah. By the way, I said I'll show. I had to show. Supriya, we have what, 10 minutes, right? Just checking.
Yeah, another 8 minutes to go.
Sure, sure. I'll just take 2 minutes and I'll show something which I said I will. In terms of the demo app, that time I could not show earlier. And if you're building a semantic search, this is the last thing, by the way. This is where I was, right? Let's say Microsoft Search. Sorry, where is that? Yeah, so I create a new one. So now here is what I did earlier, right? I imported data and I did all sorts of stuff, right? In terms of indexing, etc. Once you've done that, basically, sorry, overview, go here. And at the bottom, you see these indexes. This is where your indexes reside. So this is for the hotel sample index that we kind of chose earlier. I'm going to choose hotel sample index. And here at the top, you'll see while I can test here, right? I can test in terms of a query string. I can just try hotel and here results will come in. But for you to basically have a UI like I showed earlier, there's something to create demo app, right? You just click that and it's going to, you should enable CORS because you're going to make you're going to make a call from other websites. And it's going to give you a simple demo app. See, this is what I said, individual results, how results should be displayed. I'm saying, just a hotel name, title should be, let's say, hotel ID and hotel ID. Oops, what's happening? Hotel. Sorry, it's going overlapping there. Let's look at hotel name itself and let's look at thumbnail as, let's say category and description. Let's go with description. Okay. And let's say create demo app. Now it's going to give me an option download and that's about it. So now I'm going to just type hotel. So what you see here is exactly with no coding, you got an application. Of course, image is not linked, etc. You can fix it, but look, no, with zero coding, you're getting an application which actually brings in the power of semantic search. Yeah, I thought I'll just show that. That's the last thing I want to show. So yeah, awesome. So Sundar, you have a question. Can the OCR identify the real check and normal sheet of paper with the same data entered? You'll have trained the model. By the way, here's the deal, right? It's like the capability is to extract OCR and extract characters from any form factor. But if you want to differentiate normal sheet versus the check paper, because check will have, let's say, a watermark of the bank. There'll be specifications in terms of certain things, right? You should build a custom. That's where the custom model of OCR of a form recognizer comes into the foray. On a sheet of paper, if somebody has written something similar to check and there are no watermarks, that means it's not a check paper in a true sense. So that's where the custom model comes in. Yeah. Awesome. Rahul, integrating Python models is very understandable with ML ops, but could we integrate MATLAB MLDL model that are typically file? See, ML ops is nothing specific to a platform. It's an agnostic design thinking, right? You can apply it anywhere. So there's no mandatory in terms of what. So eventually, look at it this way. If you look at GitHub, GitHub, if those files are in GitHub and if you want to bring in automation, absolutely possible. Is it possible to perform distributed training? Absolutely. I mean, if you look at training cluster that you create in ML service that Shikha showed, you absolutely do distributed training. That's what happens when you create a cluster. Otherwise, why do you need a cluster, right? Perfect. Awesome. I think 5 minutes to go. Supriya, any closing thoughts, comments? Well,
Sure. Thank you, Shikha and Sandeep, for an enriching workshop today. I'm sure our participants have immensely benefited from the hands-on sessions, demos, and the Q&A section today. I would encourage our participants to join us for the second module tomorrow, where Shikha and Sandeep will delve into some of the impactful industry use cases of social good. We have left the registration links here on the chat window in case you have still not registered for tomorrow's session. So hats off to our presenters today.
Most welcome everybody for your time. In fact, Shikha and I would want to thank you guys for hanging on for 4 hours. 4 hours is no small time in a busy schedule. And 4 hours is pretty much half your day, work day. So we'll appreciate that. And yeah, I think any feedback, welcome. So Supriya, we have a feedback link or
We have already left the survey form here on the chat window. Participants, please feel free to provide your inputs.
Yeah, you can post it once again, Supriya, because I think that's probably a message that's gone lost.
Vijeta, can you please drop the survey form again?
Yeah, and pass on your feedback. If at all something comes away for tomorrow that we need to address, we'll address it. I mean, that's a that's a good way for us to kind of bring in some more relevance. And again, honestly, the today's bulk of the talking was done by Shikha. In 4 hours, 3 hours, she was talking. So thank you, Shikha, for your preparedness and also doing this really well. So again, for rest of the folks, tomorrow is another 4 hours. So we'll go back to our preparation after this call, after lunch. That's what it is for us. So we have to prepare so that we do a good job tomorrow. Yeah.
Thank you all for the opportunity and looking forward to seeing you tomorrow.
Yeah, thanks a lot.
Thank you so much, everyone. Wishing you a great day ahead. Expect an email coming from my end with the registration link for tomorrow's session and also the feedback form.
Sure.
Thank you.
Thanks.
Take care,
Bye
everyone.
bye,
Bye-bye.
everyone. See you all
Have a
tomorrow.
wonderful day. Bye.